Wow, we're here. It's happening.
We are here. I love that music, I have to say. Welcome,
Thank
everybody.
you. Thank you, Isaac, on my team who helped select it. My name's Claire Giordano, and this is,
I am Robert Treat.
I'm a Citus open source champion on the Postgres team at Microsoft. And you, Robert, are?
So I'm a former speaker at Citus Con this year doing the co-hosting, otherwise a longtime Postgres community avocado.
Awesome. Well, let's dive in. We've got a welcome deck to walk you through before we go to our first speaker, our keynote speaker. Let's see if we can take a look at those slides. I have a bunch of things to tell you about. I mean, the first is that this is the Americas live stream today, and we have an EMEA live stream coming up at 9 o'clock Central European Summertime on Wednesday. And then there's 25 new on-demand talks that were pre-recorded in the last couple of weeks, and those just dropped on YouTube and are available for your watching pleasure now. So you can find everything you want about Citus Con, these two live streams, and on demand at aka.ms/CitusCon. Also, I'm so nervous that I jumped right over the most important thing, which is to say that I am really excited about all the content, all the talks, all the Postgres learning. I mean, conferences are such a great way to help new people learn and spin up on Postgres and just give back to the community. So
there's so much going on with CitusCon this year. It'd be helpful if we had some kind of guide or something to sort of walk us through all the stuff that we have to look at.
Yeah, well, in fact, there is a guide. It's a blog post. Check that out. Short URL is showing on the screen. And there are 37 talks, and it categorizes them into different buckets so that you can figure out which talks are most useful to your work and the kinds of things that you want to do with Postgres and or with Citus. Also, just need to say thank you to all 40 of these amazing speakers.
Yeah, absolutely. Speaking of conferences, it's fun. It's also a lot of work. I know it was more work than I could possibly do a second time. So super happy and say thank you to all these folks who have helped out. It's been nice working with the ones that I have gotten to talk to so far. And I'm definitely looking forward to seeing a bunch of talks.
There's a code of conduct, as you might expect, even for a virtual event like this one. And it's all the things you might expect. Be respectful, be inclusive, be friendly and welcoming. If you want to see the full code of conduct or you need to report an issue, there's a URL showing on the screen, aka.ms/CitusCon-conduct. You can also get to the code of conduct from the footer of any one of the CitusCon web pages online. If you're watching this on YouTube, there are live captions in English for the live stream events. And then for all the on-demand talks that are already published, as well as, once these live talks are published within the next couple of weeks, they're not only available with English captions, but we're going to have those captions translated into a whole bunch of different languages.
Muy bueno.
There you go. Okay, Discord, the virtual hallway track. What do we want to say, Rob?
Well, I would say, I don't know how many folks joined us for the Path to CitusCon. The ones that did those events, we had a great time talking on Discord. And generally, in a normal conference, quote unquote, in-person conference, there's always that hallway track. There's always some back channel going on where you get to talk and sort of, talk about what is in the talks, but also what is going on in general. And I think we're going to have a good time in there today. I will certainly be watching, and I hope to talk to a bunch of you all there today.
Yeah, I'm going to be focused on the live stream during the live stream as co-host. But as soon as this is over, I'll be popping into the Discord, and I can't wait to, be part of that conversation. So it's at aka.ms/open source Discord, and it's the #CitusCon channel once you're in there. So please join.
Yeah, and also if you're watching, depending on where you're watching and how you're watching, that's probably the best way to ask questions to the speakers. So we'll also be watching in there to see what we can funnel to the speakers who are in the live stream today. So definitely check it out.
So here we're going to have 6 talks in today's live stream, starting with our keynote speaker, Simon Willison, and then there's just a fabulous collection of people with different Postgres expertise. So that's what we're here for. But I just wanted to make sure, jumping to the EMEA live stream speakers, that you all know that there is another completely different set of talks coming. And the URL that's showing in the upper right-hand side of the screen, aka.ms/Citus Con EMEA, that's a calendar invite. So if you want to drop it on your calendar, block the time, make sure that you're not double booked or something, that's an easy way to do it. And these folks are great, but I know we need to get to Simon's talk, so we probably can't talk about each of these amazing things right now. Oh, and there's more.
Yeah, we've got a ton of talks today, and like we said, definitely worth checking out. Check out the guide, and we'll come back. We'll talk about more about this later as the day goes on.
All right. If you are posting on social, I love it when people take photos or live tweet quotes or inspirational things that they learn from people's presentations. Use the hashtag CitusCon, hashtag whatever social platform you're using. And then for those of you who care about swag, there is an opportunity to win these really cool swag bags. There's 75 of them being given away per live stream. Use the URL that's showing on the screen right now, aka.ms/CitusConSwag. And the codes will get shared in the banners during each of the talks. So you'll need a code to enter in. And the socks look pretty darn cool. There's also sticker packs. And you can enter for both the swag bag and the sticker packs. And there's 200 sticker packs with this collection being given away per live stream. I don't know about you, but I love stickers and I've got them all over my laptop, Rob.
You know, I have to admit, I'm one of those clean laptop people, so I don't typically put stickers on it. But I'm starting a new thing, which is putting stickers on my luggage, so that it's more easy to spot that when I travel. You know, there's not as many Postgres things out in the world on people's luggage, but I think that's an easy way also to find people when you're traveling who might be into the things you're into. So
that's a really good idea. Very retro vibe too. I like that. Okay, I need to get myself some of these stickers too. Okay, there is going to be an attendee survey. This is the second annual Citus Con event for Postgres. We're going to want your feedback if you're willing to give it to us so that we can make the event even better in the future. So there's a QR code, there's a short URL on the screen. Please, and you can also give feedback on each and every talk. And if you watch some talks today and some talks tomorrow, you can come back and fill out the survey again and again before it closes on next Friday, April 28th, end of day, anywhere on Earth time zone. So that's important. And finally, did we talk about Discord already?
I don't think we did, but we could talk about it more in the Discord if we were on the Discord, and then we could talk about it with everybody who has joined the Discord.
Definitely join the back channel. It's a nice way to not just be watching the live stream, but participating in the conversation too. So without further ado, I think that we should introduce our keynote speaker, Simon Willison.
Absolutely. Welcome, Simon.
Hi, it's great to be here.
I'm so glad you're here. Okay, so for those of you who don't know Simon, he's the co-creator of Django. He's the creator of Dataset, which you'll hear a bit more about today. I've been following Simon for years on Twitter. Simon does a lot of his work in public, which means that people like me can learn from his successes, his failures, his learnings, and I've learned so much from you, Simon, these last couple of years.
I got to tell you, I lost several hours the other day after the first Path to Citus Con, no doubt, reading his Things I Learned blog, which is kind of like a micro blog of sorts. It was fantastic. And, you know, just sort of reminded me I should really get back to doing more blogging. It's really good stuff.
Yes, I should point out that Simon was a guest on the first episode of Path to Citus Con, which is this live audio show on Discord, kind of like a podcast, but with text chat. And we talked about working in public, which is a whole fascinating conversation in and of itself. But you're here to talk about big opportunities in small data. So without further ado, I think we should pass the floor to you. You've got the stage, Simon.
Fantastic. So yeah, today I want to talk about small data. And the reason I'm talking about that here is I feel like as an industry, we've got big data pretty much figured out at this point. You know, you've got tools like Citus that let you horizontally scale your Postgres database. It feels like every data warehouse product out there that I care about is adding Postgres like protocol support and so forth. Like we know what to do if somebody has petabytes of data now. That's not a difficult problem for us to solve. But I'm really interested in the very other end of the scale. The last 5 years, I've been exploring the issue of small data, where I define small as too big for Excel, but small enough that it fits on a thumb drive or fits on your telephone. My telephone's got a 0.5 terabyte of space on it right now. So small data can get pretty big. And the way I've been exploring that is through an open source project that I've been working on called Dataset. And I'm actually going, rather than talk about what Dataset is, I'm going to dive straight into a demo and show you what it is and what it can do and how it works. This right here is the City of San Francisco's Open Data Portal. And this is a trend from the past decade, which I'm very excited about, where local and national governments all around the world have been launching these data portals where they publish data about the places where people live. And some of these things are updated on a daily basis. Like, it's really interesting seeing quite how much information is flowing through all of these things. The problem, of course, is that just because you published data doesn't mean that people can actually use it. And so in this case, I'm going to do a demo using the City of San Francisco's city facilities data. And this is definitely small data. It's 1,700 rows, right? It's absolutely tiny. And what I can do is I can copy and paste that URL, and I'm going to load it into Dataset. Dataset is a Python web application. It supports plugins, which are similar to Postgres extensions. And I've got plugins installed here for things like load data from an open data portal. So I'm going to fire this up here and paste in that URL I just pasted, hit that button, and Dataset will go and fetch that data and extract things like the metadata around it, so what the columns are, and it'll also pull in that table of 1,700 rows. Now, table's not particularly exciting, but one of the Dataset plugins I'm running is it's called Dataset Cluster Map, and it looks for data with a longitude and latitude column and sticks that data on a map. So now I can click, where are we? I can click Load All down at the bottom. And now I've got all 1,700 facilities loaded onto this map. And already we're starting to see stories in the data. Like, why does the city of San Francisco have 21 buildings down here? It turns out this is a juvenile detention facility that the city owns and operates down in La Honda. If you scroll to the side, you'll see that there are things like these. This is infrastructure for the Hetch Hetchy reservoir. This is a Hetch Hetchy substation. And then over here, we've got another cluster of markers, which is, it's a camp. This is a camp operated by the Parks and Recreation Department. An important feature of Dataset is what I call faceting. It's essentially a group by and count. So I can say, you know what, let's facet by city and see that most of them are in San Francisco, but you've got some in La Honda, some in Groveland. We're going to facet by jurisdiction. Now, this is telling us which jurisdictions within the San Francisco government own the most property. And Parks and Recreation are top. Port is 213. The airport's quite big, the school district. But so just with a few clicks, with importing that data into a new tool, we're already starting to learn things about the data at a sort of aggregate level. And this is something I'm really passionate about, this idea that you can take data from an open data portal in basically any shape or size and quickly start diving into it and figuring out, okay, what are the interesting trends and patterns? What does this look like if we visualize it? Another feature of Dataset I should demonstrate quickly is all of this is running on top of a SQL database. So when I filter by 38 for public health and then 37 in San Francisco, that's building up a SQL where query for me. When I click View and Edit SQL, it actually shows me that SQL query and it lets me edit it. So I can say, you know what, I don't need any of this stuff. I'm going to keep the rest in there. I can hit Run SQL. And now I'm getting back just the results of that particular query. And that's bookmarkable. I can copy and paste this URL and send it to somebody else, and they will see that same query that I'm seeing. Even more importantly, you can get it back out as CSV, or you can get it out as JSON. And this means that Dataset can serve as an integration layer for anything that can speak JSON, which is effectively everything these days. So there's a lot of power in being able to run these arbitrary queries against a read-only database that's safe. There's no damage that you can do with this, but it gives you a very flexible and powerful way of remixing data and exporting it out and doing interesting things with it afterwards. We'll switch back to the slides. And where's my slide control gone? Sorry about this. There we are. So the reason I got interested in this in the first place was I started out actually in the realm of data journalism. So the I worked for the Guardian newspaper in London, and we realized that our journalists were collecting all sorts of fascinating facts about the world in order to create infographics and maps for the newspaper. And every time this happened, they'd collect all of this data, and then it would sit on a hard drive under somebody's desk. And we decided that we'd start sharing that data with the wider world, try and publish the data behind the stories anytime we put out one of these infographics. So we started a thing called the Data Blog, and it was a blog of data that we had collected to support the reporting that we were doing. And at the time, we ended up using Google Sheets as the mechanism for publishing the data because it was free and it already existed and we didn't have to build anything custom. But it always frustrated me. I always felt like there should be a better way of publishing data, something that was open source and more powerful and more flexible. And the question I asked myself was, what's the best possible way of publishing this structured data? And that's where the idea for Dataset came from. Dataset was my attempt at answering that question about the best possible way of publishing data that let people both explore it and also do integrations and automate it and things like that. I hinted at this a moment ago, this idea of being able to do read-only SQL queries via an API, which I find amusing because for most web applications, this would be considered a SQL injection attack. This is a security hole that you must be prevented at all costs. With Dataset, it's a documented feature. And I get away with that because Dataset it treats data as read-only, so you can't damage it. It sets a time limit on the queries, so you can't go too long with them. And it gives you that API access so that you can do interesting things on top of it. I'll show you a problem that I solved with this just the other day. This is my blog. I've been blogging for nearly 21 years about all manner of different topics. I've got a tag cloud which goes on forever with all of the different things that I've written about. But I decided that it's 2023. The cutting edge of publication right now is an email newsletter. Like email newsletters are very much back again. And I wanted to start doing that, but I didn't want to have to do any additional work for it. So since I've got this data in a database and I've got a dataset instance that gives me the ability to query my own blog, I figured I'd try and automate the process of constructing that newsletter. So I built this utterly terrifying SQL query, which pulls from all of my different content types and arranges them together into a format like this. And then I built this observable notebook. If you haven't played with Observable yet, it's a really interesting tool. It's basically kind of like Jupyter Notebooks for Python, but in JavaScript. And it makes it very easy to build custom applications that pull in data from different sources, remix it and reformat it in different ways. And so what I did is I took that terrifying SQL query, I dropped it into the notebook right here. Where's my skipped implementation? So I dropped that in. I wrote a bunch of JavaScript to glue it together into HTML and all of that sort of stuff. And then I had it output the HTML for my newsletter. And actually that's, I can click this to get rid of the things I've already sent out. So right now, if I was to send a newsletter, it would have this content in. And I added a button that copies and pastes it to the clipboard. So now I can pop into Substack and hit paste, and my newsletter is ready to send. This is also kind of a hack against Substack because Substack don't offer an API. There was no official automated way to create content for Substack. But it turns out copy and paste is kind of the universal integration method. I've done quite a few things where something doesn't have an API, but if you fiddle around with copy and paste just enough, you can actually do a lot of automation on top of it. So a sort of key hack here is to abuse Substack's ability to paste content to automate the creation of this. And this works. Now I've got Simon Willison's Substack newsletter. You can subscribe to it. I send it out once or twice a week. And it's been working out pretty well. I've been running it for a month and it's picked up a bunch of subscribers and it's been almost no work. I probably spent a lot more time fiddling with my notebook than I did actually like writing any custom content for that newsletter. And that's really that really goes to illustrate how useful it is to have data with an API that speaks SQL, right? SQL is a very powerful sort of domain-specific language for remixing and combining data. And well, some people use things like GraphQL to give themselves an API for manipulating data in custom ways. SQL's GraphQL from the 70s, right? It's worked for a very long time. It's a very robust way of doing these sort of semi-safe custom integrations. And I think there's a huge amount of power just in using SQL like that, making things bookmarkable, giving things JSON endpoints that accept SQL. There's a lot of really cool stuff that you can do with that. But crucially, Dataset is not built on top of Postgres. The database that I'm using under the hood for all of this is SQLite. It's my second favorite database after Postgres. And there are a few different reasons that I'm using SQLite for this. SQLite claims to be one of the most widely installed pieces of software in the world, and absolutely the most widely deployed database engine. It's in every iPhone, every Android phone. I'm pretty sure it's running on my Apple Watch and counting my steps, because SQLite is designed as an embedded library. It's a very, very small, very tightly written C library that you can drop into literally anything on any platform, and it gives you the full power of a relational database. A crucial characteristic is that a SQLite database is just a file. It's a data.db file that sits there on your disk. And this makes them super easy to work with. You can back them up by creating a copy. You can share them by emailing them to people. Creating a new file is as expensive as creating any file on disk. If you've lost interest in it, you can just throw it away again. So it's a very quick and agile way of working with data. But despite the fact that it's so sort of like tiny and flexible, it's also a very stable file format. The Library of Congress lists SQLite as one of their approved archival mechanisms for structured data. And that's because the SQLite team are meticulous about not breaking backwards compatibility when they release new versions. So once your data's in SQLite, it's going to basically be safe forever as something that you can then query and use in the future. And that's as somebody who cares about newspapers, that's a really big deal. And then the other idea that Dataset illustrates, which came from using, which inspired me to use SQLite, is something that I call the baked data architectural pattern. These days, deploying a web application has never been cheaper in terms of running that web application somewhere in the cloud. You've got technology like Kubernetes and Docker. Then there are hosting providers like AWS Lambda or Google Cloud Run or Vercel or Fly, who will all run a stateless web application for cents a month if it's not getting much traffic. They're incredibly inexpensive. There is a catch, and the catch is that you can't run a database in them, because the reason these things are so cheap is that they're essentially read-only stateless web applications that you don't get to write to a disk. Or if you do write to a disk, it doesn't get persisted anywhere, which makes them very cheap and inexpensive to run. But if you want to run a relational database, you're kind of out of luck. You have to pay a lot of extra money for a hosted database somewhere. The thing I realized is that if your data is read-only, none of this matters. Like once you start dealing with read-only data, and in my case, it's SQLite database files, so it's literally a blob of bytes on a disk. If it's read-only, the fact that you can't write back to the disk again isn't actually an issue. And for the world that I care about, coming from things like journalism, a lot of the data sets that we're dealing with don't ever get updated. You know, it's a snapshot of San Francisco city facilities that might be updated a few times a month, but it's not something that's going to accept constant writes. So when you've got a read-only database, there's a trick you can pull where you can effectively bundle that database up as part of the application that you're deploying onto these platforms. And now you can deploy a fully capable relational database interface that costs you a few cents a month in hosting costs. A lot of these platforms have a feature called scale to zero, which means if there's no traffic coming into your application, it doesn't cost you any money at all. The application is essentially static. Then they start the thing up running when the first HTTP request comes in. And when you've got scale to zero, it means that your costs for these sort of low traffic projects are effectively nothing. I think many of these providers here have a free tier, and it's very common for projects that get little traffic to fit entirely within that tier. So effectively, we have free hosting for these applications if you can get away with just having read-only data. And the flip side of that is that they scale up really well as well. If you want to serve millions of requests a second using this baked data pattern, you can do that by running multiple copies, spin up as many copies of the entire application and a full copy of the database in each one, stick them behind a load balancer, and you can handle as much traffic as you can throw at it. Which again, for journalism, when you have things like election results days and so forth, this is a really useful ability as well. I touched on this a little bit, but I want to dive a bit more into the fact that SQL plus HTTP is a fantastic integration tool. And I'll show you another example of a project that I run. This is a website called niche-museums.com. And it's the website I run for my main hobby, which is seeking out and exploring tiny museums. The idea behind this is If you go to a big museum, sure, it'll be interesting. If you go to a really small museum, it doesn't matter what it's about. The chances are that the person who is at the desk at that museum is the person who set it up. So now you get to have a conversation with somebody who collects Pez dispensers or runs the Bigfoot Discovery Museum. Or in this case, this is the Misalignment Museum in San Francisco, which tells the story of it's an apology from AI for destroying humanity in the future. It's only open for a few more weeks, so it's worth popping in if you're in the area. But anyway, this website is actually just dataset. This is my dataset web application with a custom index.html template so that it looks like a website. And all of the features on this, like use my location and search and the atom feed up here, those are all just SQL queries that are baked into dataset. This right here is the query for the atom feed. And if we highlight these options here, you can see that the way this works is it selects things and it aliases them as atom ID, atom title, atom updated, atom link. Then there's a dataset plugin called dataset atom, which looks for those column names. And if it finds them, it produces a link to an atom feed. So this single SQL query here defines the atom feed for the website purely by reshaping the data in SQL to that specific set of columns. That terrifying coalesce chunk at the bottom is showing how in-depth you can get with this if you want to construct, in this case, the HTML for the blog entry. And this works, right? This is NetNewsWire, the feed reader, subscribed to the feed of content from my Niche Museums website. So there's a lot of different moving parts involved here. But fundamentally, I've used a SQL query to transform data from whatever format it's stored in that website into a format that's compatible with feed readers. And then they've got a little plugin that turns that into XML. So the baked data pattern, I've done a lot of exploration of this using SQLite. A open question for me is, could you do this with Postgres itself? I'm very confident that this would work. I think there's no reason at all you couldn't put together a Docker container that contains a full installation of Postgres with data volumes and all of the stuff that Postgres needs to serve a read-only database, bundle that up with an application like a Django app or something on top, and deploy the entire thing in exactly the same way as I'm doing with SQLite. And this would give you all of those same benefits. You could get a scale to zero thing where your website costs nothing at all if nobody's visiting it. You could scale it to handle 1 million requests a second if you need to, just by deploying multiple copies of that same thing. So I think there's something very interesting that could be explored around this. And many other databases as well. Elasticsearch, for example, is something that you could absolutely bake into a container with its index data and get a very powerful search feature that costs you nothing at all if nobody's using that particular application. I've got one last demo. This, again, very much fits the theme of small data. It turns out you can run things like dataset entirely in your browser these days, thanks to WebAssembly. So I'm going to switch over to my demo again and show you a thing that I built called Dataset Lite. Could we switch to the demo feed? Oh, my fault. My screen sharing stopped. I'll just fix that now. Window. Here we go. Okay, we should be, there we go. So Dataset Lite is dataset running entirely in WebAssembly. So I've opened up the network pane here so you can see what it does. In the left-hand side, it's loading up dataset and installing packages and so forth. On the right-hand side, you can see it downloaded something called pyodide.asm.js. And pyodide.asm.data. This is a full Python interpreter and the Python standard library bundled up for WebAssembly so that it runs in the browser. So right here, I have a server-side web application, like Dataset is a traditional server-side app that's running entirely client-side, and most of the functionality is working. I can facet and I can run SQL queries and all of those kinds of things. And I built this actually as a joke. I thought it would be amusing to show that a server-side web app can run client-side now, but I didn't think it would be useful for anything. But since I built it, I found that I'm using it for all sorts of different purposes, mainly because it's 100% robust, right? There is no server. This is all just HTML and JavaScript. There is nothing that can break with this, which means that I can build things on it and share them with people and not have to worry about hosting bills or the thing might break in 10 years' time or anything like that. So just yesterday, a project called Red Pajama released a training data set for building ChatGPT-style language models. They released it. It was over it's 1.2 trillion tokens. And this is how they released it. It's a file called urls.txt with 2048 URLs in it. Each of these is like a gigabyte large file, which you can then download. And to gather all of this stuff, to download all of it, you'd need 2.7 terabytes of disk space. I do not have 2.7 terabytes of disk space, but I still wanted to get a feel for this data. So I wrote a little Python script that did a head request against each URL to get back just the length of that file. And I turned that into a JSON array. So here we go. This is saying that file there is this big, and I've got megabytes and gigabytes as well. And its top folders are these. Very, very simple. And what I can do now is I can click Load JSON in Dataset Lite, paste that URL in, and it'll import that JSON document and turn it into a table. So now I can start answering questions like, what are the top folders? It turns out that Wikipedia, there's only one file. I think if I sort by size, I can see that Wikipedia is the largest file. They have a 111 gigabyte file you can download with all of English Wikipedia in. But this project here took me 5 minutes to knock together. I've got an article about it on my blog. I literally did the whole thing, copied and pasted it into a gist, assembled this, and then started sending people this link. So, running a database in WebAssembly is actually a really interesting trick. Excitingly, you can do this with Postgres as well. This right here is a project that Crunchy Data built to provide an interactive tutorial for learning SQL. And this is a full Postgres running in your browser. This was actually inspired by my work on Dataset Lite. There's one catch. It's a 50 megabyte download to get this working, because they ended up having to do a full virtualized Linux operating system with Postgres running on top in order to build this. I'm very confident that with a lot of extra work, you could shrink this down and just run Postgres itself. And that brings me to my sort of call. Where are we? Oh, could we switch back to the slides? And so the thing that excites, the reason I use SQLite for so many of my projects is that SQLite is a genuinely serverless browser database. It doesn't need a server, and this is the original meaning of serverless before it meant whatever it means today in the cloud. There is no server. SQLite, it's a file on disk. It's a C library that opens that file. Everything is done without network connections. And that's really powerful and useful, and something I'm seeing more of these days as well. DuckDB has become popular over the past few years, and it's exactly the same idea as SQLite. It's a library you can install, and then you can do it. It gives you columnar sort of analytical database. So like SQLite, but optimized for those analytical queries. And it's really cool. It's a very exciting piece of software. My question is, could Postgres do the same thing? What if there was a sort of a bundled version of Postgres that existed without the network stack, without the sort of server side of it, but it gave you access to the core Postgres, core Postgres SQL and data structures and so forth, in a way that meant that me as a Python programmer could pip install it? I would love to be able to say, pip install Postgres lib, or npm install or whatever, import it into my Python code, and then use it like I do SQLite and DuckDB today. This would give me the best of all worlds. It would give me the feature I care most about from SQLite, but it would also give me Postgres' far richer and far more feature-complete version of SQL. And it would give me access to PostGIS and extensions like that as well. So this is kind of my dream. I think if this happened, I would drop SQLite in a heartbeat, and I would be building all of my stuff in Postgres again. So the idea is to take away small data. It's really cool. It deserves more tooling. It's worth thinking about how you can build tools for the small end as well as for the big end of the scale. The baked data pattern is a way of scaling read-only data both up and down, which I think is really powerful and gives you a lot of options for interesting deployment strategies. Read-only SQL APIs are a great idea. Forget about SQL injection. It's fine. Just if it's public data, let people SQL inject all that they like. And yeah, you can run databases in the browser now. I'd never thought I'd see the day. And if you're looking for a very complicated side project, please build me Postgres as a library. I would really appreciate that. And yeah, that's all I've got for you today. I will be on Discord for the rest of the conference, and very keen on talking about this. And yeah, I've got time for questions.
Awesome. There was a number of different things I loved about that. Somebody mentioned in the Discord about the original start with looking at data set and how it really opens things up to the idea of like, let's go explore the data, not like, here's some pre-compiled thing that you should look at in this data. It really is about exploring it, which I think is really fantastic. So that was pretty interesting. And now I feel like there's a bit of a call to arms. I sort of wanted to ask a little bit about how you integrate this with Postgres. How much have you looked at that? And I see that you've kind of got some call to arms in there on like, well, here's what you could do with more Postgres in there.
So I've actually built that a little bit. Last year, a couple of years ago, I built this thing called Django SQL Dashboard, where the idea, because I had a Django app that I wanted to do dataset-like things against. And so this is a little Django application I built, which works against a read-only Postgres thing and gives you some of that dataset functionality. The longer term, I would love dataset to have pluggable backends. If dataset could talk directly to Postgres, I think that would be phenomenal. And I've shied away from doing that because then I have to build every feature for SQLite and for Postgres. But I'm beginning to grow a hunch that that's not as difficult as I thought it would be. The SQL dialects are very similar between the two. So it might happen.
Yeah, absolutely. I've had the opportunity to talk to Richard Hipp from SQLite a number of times, and he's always stated that he looks at the Postgres, syntax and language as sort of a first implementation for him to base what he does. So I think that would actually be pretty easy to make that all put together. So sounds awesome.
What I like about your talk, Simon, is just that you're looking at Postgres from right next door, right? You're not actively spending all of your days working on Postgres, but you are solving similar sorts of problems with other tools. And I think you and I talked about this as a Postgres adjacent talk.
Absolutely.
When we were first conceptualizing it. And I think it's great because you see things in a way that's different from those of us who are like in this circle all the time. So
I would actually love to chat more. I think we are
Discord.
Pushing it for time. Yeah. So there are questions in the Discord. I will be checking that out as well. But I think we actually need to move on to our next speaker, sadly.
Simon, thank you so much for being here.
Absolutely. 100%. That was awesome.
Thanks very much for having me. And yeah, I'll be on Discord in just a few seconds.
And thank you for your Path to Citus Con episode 1, which I hope people catch. Really, really interesting conversation on working in public too. Cool. Have a great day.
So our next speaker is going to be Jelte Venema, and he is speaking, ironically, because of the little niche museum in Simon's talk. I love that, like, here's the apology from AI for destroying the world. So of course, up next, we need to, and this is not planned. We need to have a talk about ChatGPT and Postgres and Rust and all that. So that's fantastic. How you doing, Jelte?
I'm doing well. Yeah. So I'm very excited.
You're joining us from the Netherlands?
I am, yes.
Excellent. So just for those who have not met Jelte before, he's a senior software engineer at Microsoft. You work on Citus and on Postgres, and I believe you're a maintainer on PG Bouncer?
Yes, all of those.
Yeah, so we all owe you a few beers, I imagine, for that for work across the board. So excellent.
Or coffee. Coffee works too.
Or coffee, yeah.
Okay. Well, Jelte, take us away.
All right. So I'm going to talk a bit about this whole thing with AI that if you've been on the internet the past few months, you saw happening, that sort of taking over the world. Everyone's like, oh, what? You can now do everything with AI. You can create pictures. You don't need to paint anymore. You can do anything. You don't need to Google. You can just ask AI and it knows. So I'm here a bit for how can you use this AI for Postgres? What can you do to integrate it with Postgres, and how can you use it in useful ways? And that's going to be my talk. So the reason I'm doing this talk is because I have one secret problem. I've been working on Postgres with Postgres and on Postgres for quite a few years now. And I still have a very difficult time to write working Postgres queries. I don't know what it is. It's just I forget a comma. I swap around order by and group by, and then it's like, oh, it's the wrong order. It doesn't work at all. I forget how many parentheses I need for a values statement. All of those things can happen, and I don't know. My queries never work first try, and I don't think I'm alone. At least I hope. So in the past, it was always just sort of a given. It's like, okay, I just write the query again. But now with AI, I was like, maybe I can ask ChatGPT to help me. So that's what I did, and ChatGPT was like, yes, of course, I can help you. What do you need? And I was like, okay, well, what do you need to know from me before? What do you need me to tell you for you to help me? And it wanted to know some tables and column names and like the things I wanted to do, of course. So and then I thought that's a bit annoying. Then I have to copy paste my schema from my database or from some file into ChatGPT, so it knows all the tables and the columns I have. And that's another problem I have, although not so secret, is that I don't like doing boring things. And copy pasting schemas and queries, to me that sounds extremely boring. So I thought, how can I avoid this boring stuff? And because Postgres, it has all this information, maybe I can get Postgres to communicate to ChatGPT for me instead of doing it myself directly. And that would need some functionality in Postgres to be able to do that. And that's actually quite possible because Postgres has extensions. It's one of the things that make Postgres quite special with respect to other relational databases. It's actually in the original paper for Postgres in like the abstract that Postgres it's one of its goals is to be extensible. And the way it does that is that you can define your own types, your own functions. And how you do that is by having two parts. You have a shared library, which contains all the native code. So that can do anything, basically. It's like any program running on your computer can make web requests, can do whatever. And then sort of to call that native code from a SQL function or from a SQL query, you define some SQL functions. And those SQL functions are very simple. They're like, this is the name of the SQL function. This is the things it returns and the arguments it takes. And this is the name of the native function that it will actually call internally. And Citus is built like that. Lots of other things are built like that. So I thought, well, let's write a GPT Postgres extension. How hard can it be? And there's one other thing about me. I like Rust. It's like this fancy new language. It's not super new anymore, but it still sort of feels new. All the things about it feel new. It has like everything is an expression. So even your if and your else, they sort of return values, and you can do pattern matching, which is like it's sort of destructuring of structures and structs and objects, and in sort of a way that it just looks nice in code. And it's hard to explain if you haven't seen it. Just go look at it. And the type system is also fancy. It's like Haskell, but I can actually understand what it does. And it will give you things like not having no pointer exceptions. And on top of that, there's also extremely secure. There's no memory leaks, no double freeze, no data races, none of those things that you're used to from C or C++, and data races can happen in pretty much any language. But even those that don't, if you're doing sort of in the correct way, they don't happen in Rust. And even with all those security things, it's just as fast as C++. And C. Although it doesn't really matter for our use case, because I just want to talk to ChatGPT, and probably ChatGPT is the slow thing in this whole setup. But we can at least send questions to ChatGPT very, very fast. How long ChatGPT takes to respond, that's another matter. And finally, not unimportant, it has a package manager. And C and C++ they famously don't, and managing dependencies, it's horrible. That's kind of So package manager in Rust is good. It's like any other package manager for most languages, but C and C++ they don't have it. And finally, sort of bonus thing, it has this really cute little crab as a mascot. He's called Ferris, so that's bonus points for cute mascots. So I've actually been playing with Rust for quite a long time. I have a fairly popular open source library called Derive More. and it automates writing boring boilerplate in Rust. So you might see some things in the things I work, some commonalities in the things I work on, where I'm trying to automate all the boring things away. That's kind of what I do. And I actually did this 7 years ago. I started with it, and it grew way more than I expected, because apparently other developers also don't like doing boring things. So now it's actually used by more than 100,000 repositories on GitHub. So it's quite, definitely my most used library for sure. So I never used Rust professionally. I only did this sort of as like, I started doing this at the end of my university, and then I sort of did it outside of work. I sort of continued a bit with it. So that's something I kind of want to change. So how do I combine Postgres and Rust, and maybe even Citus? Because I'm working on Citus most of the time, so I could even sort of pull Citus in to make it more relatable to work, and get Microsoft to pay me for doing stuff on with Rust. And actually, I'm not the only one that wants to combine Postgres and Rust. There's this great PGX library, and I just learned today that in the last 24 hours they changed their name to PGRX. I guess the R stands for Rust. So anything that says PGX in the next slides, it's probably it will be PGRX tomorrow. But yeah, I couldn't change my slides anymore in time. But there's a Rust library to build Postgres extensions with Rust, and that's kind of just what I want to do. And it's actually really easy to use. It's a few commands. You install Cargo PGX. Cargo is the Rust package manager, and you can install some plugins to it. So by running cargo install Cargo PGX, you can then run Cargo PGX in it to sort of set up Postgres extension tooling. And then you can create a new extension. You can do Cargo PGX new, my extension, and you go to the directory of the extension and can play around with it. That's in the README of the project. And but that sort of brings us to the next issue. I need a name for this cool new GPT extension. So sort of the most obvious one is PG-GPT. But it turns out that I wasn't the only one with this nice idea of combining things. So someone else sort of did exactly what I wanted to do, but I already submitted a talk, and I still think I already started working on it also. So it's of course it's different. Mine is obviously better, but yeah, but I should at least not take the same name. That's just confusing for everyone. So maybe flip it around, go for GPT PG. And it's a nice palindrome, so that's kind of cool, but it's kind of hard to pronounce. The only reason that rolled off my tongue so easily because I practiced it a lot. So I ended up at the final choice of PG Human. It doesn't contain GPT, but it sort of brings the idea to you, we want to humanize Postgres so that it's not such a machine anymore. It becomes a bit more human. It understands you better. So I double-checked with ChatGPT if it thought it was a good name for the extension, and it was like, yes. Oh yeah, it's a great name, short, catchy, easy to remember. So I was like, okay, well, if ChatGPT agrees, I will use this name. So I continued. I changed my extension to PG Human. So now we have a directory, and then in the directory you run cargo pgx run, and you create the extension inside the Postgres shell, which is cargo pgx run actually spawns the Postgres shell automatically, so you can play around. And then you create the extension, and then it has even as a built-in hello world. So you have an extension that works. It doesn't do very useful things yet, but it works. So then I wanted to make some changes because I wanted to make it do useful things. So I made some small changes. I recompiled, and then it took 7 seconds to compile. So that's not really, it's not super slow, but it's slow enough that it annoys me. So I looked into it a bit, like, why is it so slow? And it turns out that one thing that makes Rust compilation and compilation in general slow usually is linking, which is compilers, they create multiple files, and then they sort of merge them together in a final binary that you can execute. And that step, it's done by the linker, combining those files. And the GNU linker, which is sort of the default one that you get on Linux, it's a bit slow. So it's very easy. You can swap it out for a faster one. Molt is fast. LDD is fast. LDD is from the Clang people, and Molt is from someone else. But I tried Molt, and it was like, three lines in some file in my home directory, and then it took only 1 second to compile instead of 7. So that's okay. 1 second I think is acceptable. That's fine. My change compile cycle is not impacted so much by that. So now we can actually start. So what do we actually need in this extension? First we need to get the schema definition. That was sort of the whole point. We wanted to avoid copy pasting that schema definition. And then we need to send it to GPT because that's sort of the paste part. And then, we get some query back that we might execute. And we kind of don't want to copy paste that either. So we just want to execute that. I'm not going to read it anyway. That's way too much work. So I'll just trust that it sort of does what I want and execute it right away. And then if that query is like a select where you want to fetch some data, that should actually also return that data, not just run and then throw everything away. So we need to sort of return arbitrary SQL results, because all the queries, they can, you don't know what kind of query it is. It can have many columns or just one. So let's start. And getting the schema definition is actually not super easy. Postgres somehow doesn't have like a built-in way to do this, which is very surprising to me. So, it's also not the worst. There's like sort of internal tables from Postgres that you can look at to see what tables exist. And I just did that and looked at the column names and sort of concatenated strings together to turn it into something that looked like create table statements. And then I had like a schema description. And then I need to send them to ChatGPT. And it's very easy to do that. You can install the OpenAI package for Rust, and Cargo is this package manager again. So it's like a one-line command, and you have a ChatGPT client that you can send questions to. And then you need to make those questions. So we first start with giving the AI a little bit of confidence. You want it to really give you the good answers, and it only does that if you tell it they're an expert. So they're like a Postgres expert. Otherwise, maybe they're just saying dumb things. But if they're an expert, then they will never do that. So that's one thing. Then you want to tell it what you have. Like, this is my database schema. That's a second thing you send it to. And then you tell it what you need. Like, I have the schema, and I want you to give me a query that does this normal human description thing. And then finally, also really important, you tell it what you don't want. So you don't want all kinds of fluff around it with things that you don't care about, like just sort of descriptions. You just want the raw SQL query. That's all you need. And you don't want it to make up tables that don't exist. The things you're sending it's all the tables that are there. So if it thinks there's other tables, it's like, okay, well, that query is never going to work anyway. So you try to suggest to it that it shouldn't do that. And that's the important part. It never really completely listens. Most of the time it does, but sometimes it just ignores your advice. But yeah, people also do. But there's one issue with sending these requests, and that's that Rust, it loves async and threads to make everything go fast. And async support in PGX, it doesn't really exist. I opened an issue on GitHub to sort of discuss a bit how we could make that better. But at the moment, there's not really a nice solution. And Postgres and PGX really don't like threads. Nothing in Postgres is thread safe. So if you spawn multiple threads that touch Postgres things, everything is gonna go horribly wrong. But luckily, there's a really easy sort of workaround. You can just tell the Rust async library to run everything on the current thread. And then you don't use threads. It won't go as fast as it could, but that's fine. We're only sending one request at a time anyway. So we might as well do it on the current thread. And then we get some query back that we can execute. And then we need to execute that. And Postgres has SPI, which is Server Programming Interface, which is like a C bindings for running SQL in an extension. And PGX has really nice Rust bindings for those C bindings. So it's just as simple as you get a string of SQL and you say execute, connect SPI, and then execute this SQL. That's all you need to do. So this was actually very simple. But the returning arbitrary results is where it gets a bit more complicated, because all you can do with the Postgres extension is create functions. And functions, they need to have a known set of columns. You can't change those columns on the fly or while running the function. Postgres needs to know what columns that function is going to return. So that seems a bit of a problem, but actually it's not so much. We are not running any SQL already anyway, so we're sort of doing no SQL kind of things. So we might as well go fully no SQL and start returning JSON blobs. So that's what we're doing. Postgres can transform a query and return one JSON blob. So we have a function that returns only JSON, like a single column with only JSON. And that's kind of, I mean, and you wrap the actual query that you get from ChatGPT in like a little bit of wrapper to turn that query into returning JSON. And then you have something that works. So now it's time to show that all this sort of does what I tell it does. So we're going to hope that AI is doing the right thing. But I didn't know really what kind of demo I needed to do. So I asked ChatGPT again. I was like, to-do list app, that's a good demo app. I was like, okay, well, that seems reasonable. So let's do that. I will start typing now. And so the thing I do is let's first create some tables. And as you can see, I'm calling this function. I'm feeling very lucky. So it's this is changing your database with something returned from an AI that might or might not do exactly what you want. So I think it's a well-named function. And what we're going to do is we're creating tables for a to-do app with multiple users. And when I run that, it's going to think for a little bit. And if we scroll up a bit, you can see it created a table with users, and it created a table with tasks. And user ID, description, due date is complete for all the tasks and names and emails. So that looks pretty reasonable. But the due date seems a bit unnecessary. So let's remove that column. We don't really care about it. And ChatGPT happily obliges. It runs an alter table, drop column, due date, even though we didn't specify what table it was, or that there was an underscore between due and date. It sort of understands what we mean. And if I look at the tables that we have, we need to have the tasks in the users table. So now we need some data to show some nice queries. And creating dummy data is always quite annoying. You have to think. And I mean, ChatGPT can think for us. So let's add 3 famous football players and have 3 tasks for each of them. Based on their training schedule, to have some nice relatable data. And we wait a bit. This usually takes a bit longer because ChatGPT, it creates tokens, and each of those tokens cost a bit of time. But this time it was fairly fast, only 7 seconds. But because it's actually creating quite a bit of data, so it takes more time to generate that than a simple query. And as you can see, it's like it adds Messi and Ronaldo and Neymar. I mean, I'm not a huge football fan or anything, but I mean, those even for me, those are names that I know. And it even knows sort of the football clubs that they're from and uses those in the email. So it's really nice touch. And the tasks, they also sort of make sense. They look like football things that you could train. So yeah, let's see if anyone completed some of their tasks. If there's any completed tasks, you can check like the public task, and it will create a query. It does is complete is true, but there's currently no one that completed any tasks. So let's change that. Let's add some random. Let's complete some tasks randomly. So we randomly complete 50% of the tasks, and it takes a bit of time, but then we get a query back, update tasks set is complete to true, and then where ID in something, I don't know, so some query with some random part, so that seems reasonable, times 0.5, so that's probably the sort of the chance of it happening. So that, I mean, I don't know the exact details, but it looks about all right. So let's take a look again at let's show the completed tasks again. Yeah, you can see like, oh, there's 5 completed tasks now. They might not be entirely random because it's like 5, 6, 7, 8, and 9, but maybe, who knows? It could be random. And now we kind of also want to know who's completed these tasks, and we only see user ID 2 and 3, so that's a bit annoying. So let's show the amount of completed tasks by user and include the username, just so that we know what football player is actually doing their training and which one is not doing anything. So we wait a bit again, and we can see that Neymar is clearly the one that's actually training a lot, and Ronaldo is behind. But Messi is just, I mean, he's probably old and not, I mean, he thinks he's done enough. So we have, and the query, it's actually not a super easy query. It has like a join on like the columns that are actually there, and it does a group by, and it thinks of all these, I mean, it does all the things sort of in a way that makes sense. So it's quite impressive to me. And that's kind of the demo. But one final thing is, after demo, I usually like to clean up because I don't like leaving tables around so that they mess up other tests that I do. So let's sort of remove, delete. Let's just delete all the tables at the end. So we drop table and it deletes the tables very happily. So this is one of the reasons why you probably shouldn't do this all the time on your production database. I mean, whatever you tell ChatGPT, it will execute, and it's totally fine. And that was a demo. And so where can you find this amazing Postgres extension? It's open source. I just published it like 5 minutes before my talk. Definitely use at your own risk. It's more toy than production project at this moment. But it's fun to look at. The code is quite easily understandable, I think. That's yeah. And there's a few things that for future improvements or like future fun things to maybe add to it. It's like explain plans, because those are usually hard to understand. Index suggestions, like what columns to index for your queries. And also for Citus, it's like distribution column suggestions is another thing. It's sort of even harder than index suggestions because you can only have one distribution column, and it's not always the primary key. It's you have to think a bit about your schema and your queries to do something intelligent. That's that was my talk. Are there any if there's any questions, I'm happy to answer some.
Okay, so that was a delight.
Yeah,
oh
that
my
was great.
goodness. Okay, so we want to know, did you actually write the code, or did you make ChatGPT write it all for the extension?
So I wrote it all. There were some examples. I know one of my colleagues, Marco. He did use ChatGPT to use PG, like to tell ChatGPT to create some other extension sort of template. So it sort of knows about it seems. So that's yeah.
And you just mentioned Marco Slot, who's giving the keynote talk in the EMEA Livestream. That's
Yes.
tomorrow, Wednesday. Just throwing in that shout out there. All right, Rob.
Yeah, I loved at the end where you're like, be careful what you tell ChatGPT to do. Earlier when you said like, let's remove the column, and it like drops the column, and I thought like, wait, was he removing that from his select statement, or did he mean from the table? So I'm just waiting for the day when it's our first, like delete without a where clause because of ChatGPT. Like that will eventually be a thing that somebody has to tell their boss, I'm sure. So
yes, for sure. That's going to happen.
On a slightly more serious note, so now that you've kind of played around with this Rust extension, and by the way, thing I learned that they just changed their name like earlier, within the last 24 hours. So I think that's good long term, but interesting timing. I'm curious when you would maybe recommend to folks to use Rust for an extension versus trying to do it in C.
So I actually think it's easier in Rust, sort of for everyone, honestly. I mean, unless you're really like a Postgres core developer, like that works on Postgres a lot, I think it's easier to learn Rust, and even the setup is so much simpler than having like creating an extension in C. You have to do lots of things. You have to look at make files. It's all very annoying and hard if you don't have sort of the experience with it. And with Rust, it was a few commands, and you had something set up, and there's some examples and that you can look at in the repo. So it's really, I think it was easier to write an extension in Rust than it was in C.
So I know you work on the Citus extension to Postgres. Are you saying that if you were to start the Citus project today, you would be proposing to implement it in Rust?
I think the Citus one might be sort of a special case because it interacts so much with all the Postgres things. So it's kind of useful to be able to copy paste some code sometimes that is not really exposed in Postgres, but we kind of still need. So that, and if you have Rust, you can't simply copy paste C because it's a different language.
The team is secretly writing a bot to just like rewrite the whole Citus extension into Rust like over the summer or something. Like
I don't expect that to happen very time soon. But we're definitely investigating we're definitely using Rust for some other extensions.
Well, thank you so much, Jelte. I know Rob wanted to ask questions about the pronunciation of Postgres.
Yeah, I just wonder, can you get ChatGPT to actually call it Postgres instead of PostgreSQL?
I have not tried, but I think if you ask it sweet enough, I think it might. That's kind of it listens most of the time, but so sometimes it has its own free will and does something that you don't want anyway. That's what I've kind of learned. Because even if you tell it like, oh, you don't only want the SQL, the raw SQL, sometimes it still adds like, this is the SQL right in front of it, and then when you execute it just doesn't work because that's not the SQL that you want to execute.
Well, Rob, when we look at our checklist, we can check off like discussion about the pronunciation of Postgres, because you can't have a Postgres conference without having that discussion. There.
Somebody's working on their bingo card right now. So yeah.
Thank you so much, Jelte. You are going to be co-hosting the EMEA Livestream. So for people who come to that, we will see you again tomorrow. And for those of you who want to mark your calendar, that's happening Wednesday, 9 CEST. And there's a calendar invite URL showing on the screen right now. So thank you. This is awesome.
Yes. See you tomorrow.
Rob, do we have an interstitial video next? Is that what's going on?
I believe we do. Before we jump to the next speaker, we wanted to kind of highlight some of the on-demand talks that are available. And there are 25 of them in total. This will be just a preview of a few of them, but so hopefully gives people an idea of what else is out there who haven't, gone and read all of the guide yet. But here's a little preview.
We are so happy that so many of you are joining us for Citus Con, an event for Postgres 2023, now in its second year. I want to make sure you know there are 37 talks in this year's lineup. Not just the 6 talks in the 2 live streams, but there are 25 more brand new talks. We call them on-demand talks, and they're going to publish on YouTube at the very start of Citus Con. Lucas Borges is giving a demo about how to auto-scale Azure Cosmos DB for Postgres using Grafana and Azure Serverless. Hockey Benita is giving a wonderful talk on unconventional ways to index UUIDs in Postgres. Hedy Dombrovska is presenting on temporal features and time travel. Adi Kumarachat is going to cover partitioning strategies for Oracle to Postgres migrations. Bruce Momjian is giving one of his many talks on artificial intelligence and Postgres. Paolo Melchiorre is going to teach us how to build a web map using Django and PostGIS. And Chelsea Dole has a great talk on Postgres table bloat. And there's even more. You can find all 25 of the on-demand talks at aka.ms/CitusCon-on-demand.
All right. Awesome stuff.
Let's dive in. I know that we spend too much time asking questions of Yelta. So I think we should bring our next speaker on.
Yeah, let's go ahead and bring in Ivan Vesmetinov, who is
Hello, everyone.
Technical lead in Accidental DBA. How you doing?
Perfectly fine, thanks.
Awesome. He also is Citus open source user and is going to be talking today about JSON and analytics and putting all that together. So let's turn it over to Ivan and we'll get started.
Yes, hello everyone. This talk will show you a successful example of real-time analytics based on semi-structured data, JSON, and how Citus helps with shortcomings of that. It will be especially useful for those who considering JSON-B for such workload, to know caveats, tips, and tricks, and again, how Citus help you with distribution capabilities. Now, here is my short info and my socials. We are a company that makes social and mobile games. You might have heard about Klondike Adventures. That's us. There is also a short list of our achievements, and we are also big believers in open source and encourage every user of open source to join the contributing community. Now, with that out of the way, let's get started. So, first, I'd like to discuss the division of labor in our company. Here we have my department, internal tools, which is essentially a data engineering department. So we extract data from various sources, we prepare, clean it, and store it into a data warehouse. From the other side, there is an analytical department that uses data we prepared from reports, machine learning tasks, etc. And this talk will mostly focus on the data engineering stuff. Now, to our analytical solution, right? The general vibe of our solution can be described as ingest everything, every piece of data, as fast as possible, and with any computational power available. This comes from the following set of initial requirements. From the start, we were required to have solutions that are capable of storing semi-structured data, because we, as you may have noticed, have a lot of games, and each game has its own unique analytical events with unique content per user. So the solution should accept that data at real time. It should be scalable to support increased demand, if any. It should store that semi-structured data of users efficiently and allow to efficiently query it via SQL. And now Citus comes to play. But you may wonder why exactly Citus and not Timescale DB or ClickHouse or Yugabyte DB, Cockroach DB, or any other available technology on the market. Well, allow me to answer you with a list of pros and cons, but it will be a little bit dated because we were making our choice 6 years ago. So now, Citus is open source technology, especially now. It supports JSON-B natively because it is an extension of Postgres. These JSON-Bs are conveniently queried via SQL, familiar to our users, and the Citus itself is a OLAP-centric extension, so it was built with the OLAP use case in mind. From the other hand, there were no columnar storage back then, typical for OLAP. and there were no convenient way to scale the cluster in open source edition. It was behind the paywall. Luckily, today is nowadays, and both of those issues are resolved. They are open sourced, and thanks Microsoft and especially Citus team. Now, let's see the hardware that we have for that. We use an on-premise installation due to some historical reasons. Here you can see our coordinator machine specs, and here are worker machine specs that we have 40 of. Now, we rely hugely on huge pages, 1 gigabyte in size. We disabled swap, and Postgres configs just reflect the hardware that we have. We also picked Btrfs as our file system. It's a great file system. Being copy on write, it provides us with the ability to make file system level snapshots, which are a perfect solution for quick backups. But more importantly, it is capable of compressing data that it manages. So using Btrfs, we gain a compression ratio about 6:1 using the comp size tool. And that's essentially how we solved the data issue with JSON, because as you may know, semi-structured data is very space demanding. It is great. It's 6:1 is a great ratio for us, but it could have been better if we played with the size compilation flag from the beginning. But yeah, that time has passed. So now let's see the described solution itself. Here's our example of our data that we accept in our system. The first 3 fields are essentially a primary key of an event. And data field can contain any JSON that is required for customer. In order to store that in Postgres, we dynamically create tables that correspond to the event name, and other fields go as is, essentially. But there is also a special profile events designed to store common data for events, so it's like normalization. There is a permanent profile, which is actually updatable entity. So it is designed to store data like register date or country, something that doesn't change over time for all events. And there is a volatile profile for things like user level or something. It is similar to events. It is not updated. It is stored. But upon insertion, we calculate a range of activity for the profile. So the profile considered active from the update time where the profile came to our system and up to the next profile for that users. Combining all this together, we get the base for most of our analytical queries. So this join represents like 95% of queries that are performed in our system. And since this is per user analytics, all of our tables presented here are distributed by the user ID column. Now, I also should mention that we have more tables to support integration with partners like AppsLayer, Google, etc. But it is a big part of our analytics, but it is not a part of this topic. Maybe next time, this talk, sorry. Maybe, yeah, next time, next session. So let's see some actual results of this. Here you see the statistics that we gathered from PGStat statements extension in about 2 months. And as you can see, the vast majority of our analytical queries runs under 30 seconds. Here is a quick plot to demonstrate it visually. And now let's discuss how we gained it using JSONB as our main type of data. So there are 2 caveats that you should be aware when you're using JSONB. First, the JSONBs get toasted, because they are not restricted in size, and essentially, if they get toasted, it will hurt the performance. But secondly, and most importantly, Postgres still does not gather planner statistics for JSON-B content. Essentially, what it leads to, if you have some query that uses JSON-B in where clause, your rows get very underestimated, extremely underestimated, and you will get suboptimal plan. So what can we do about that? Well, to battle toast, we advise our clients to use thinner events and bigger profiles, so the vast majority of events won't get toasted, and profiles will be kept in shared buffers. It can go even further via restrictions, via check constraints or something on the middleware side, but we do not recommend it. It's too restrictive. And you can play around with table settings or even compilation setting for Postgres. But once again, we did not try it. We didn't even need it so far. Now, statistics. First, what you can do with statistics is just accept it. Accept the fact that some of your plans will be suboptimal and maybe add more computational power to it. But if you need to see correct row estimation, so you can spend some space on disk and create a gene index. This is a special type of index specifically designed for composite values, and most importantly for JSONs, is that it supports JSON path expressions. Here's an example of gene index and JSON path expression, and as you can see, row estimations got much better. It's a great solution. It covers all fields, all columns within it. But unfortunately, it is much slower than B3 index because it uses bitmap index scans. And JSON-Path itself, while being pretty powerful in capabilities, it is not very readable and reminds me of regular expressions. And it can get very ugly and very fast. So now let's talk about those B3 indexes. Well, that's quite simple. You can create them on this arrow operator, and with B3 index present, the performance is the best. The row estimations is most accurate, etc. But you'll have to create it on each column of JSON separately. Now there is also an ultimate answer for all our performance issues, statistics, toast, etc. Just add raw computational power. I mean, optimal plan or suboptimal, if you have enough computational power, your queries will perform adequately. And of course, it's mostly joke. It won't solve all your problems, but again, with Citus, it's a very great option to have sometimes. Now we also have some default indexes that we create for all games to support our base join, right? But we also sometimes need to resort to denormalization because our data can get very big. For example, our biggest table is 28 terabytes in size, and indexes or no indexes, this join with profiles will not perform well. So what we do instead is just store that value in the event table itself. In order to do that, we just create a corresponding column, write a simple update query that fills that column using the select you saw on the previous slide. This update is wrapped up into nice callable procedure, and the call of this procedure is scheduled when it is appropriate for us. Using this approach, we eliminate the need of this slow join, and it gets great results. But from the other hand, now we have some historical data with this column field and fresh data where it is not filled. No problem. If you know the threshold of filling, you can just union fresh data and historical data. It is similar to MatViews. This approach is similar to MatViews might be, and let's see how Citus handles them. So here is a typical analytical query, and when we want to store it on disk, we just create MatView and schedule its refresh. Right? All simple, all okay. Now with Citus, you just create MatView, invoke redistributed table on that MatView, and schedule its refresh. Now it's joinable with all other distributed data in our cluster, right? Nope. Unfortunately, there is no way to create a distributed MatView in Citus, and it is by design, because developers suggest us to use insert into select functionality instead. No problem. In order to do that, just create table, regular table distributed, and write a truncate insert procedure that mimics essentially materialized view functionality. Now, all right, that's the gist of our solution. Now let's see how we perform maintenance of all that beautiful beast. So our maintenance is essentially split between the developers who write ingesting middleware, because some tables just essentially a part of that middleware. But it is wrapped into DBA maintenance that creates infrastructure, databases, etc. roles for that middleware. But from the other side, it creates views and indexes on tables that are managed by middleware. But either way, both parts are managed by a Flyway database migration tool, which allows to store changes to database in a sequence of version migration scripts. Now our DBAs follow the GitOps approach. It means that we have a single repository with automated delivery configured, and every change to the database is performed as a commit to that repository with a migration script. Very convenient, auditing log, etc. Now let's see how we handle multi-tenancy, because we have a lot of games. Each game is essentially a tenant. So there are preferred ways to do multi-tenancy in Citus. There is a way where you have a tenant column in all tables, all distributed tables. It is the way described in the documentation. You can also have a schema per tenant in your database. We went another way and created a database-based multi-tenancy. So we created a database per tenant, because we like that strong isolation between tenant. We like that we can have a custom configuration of database per tenant, especially Citus configuration. So we can have different workers for different databases. It was not so easy back 5-6 years ago. Yeah. And surprisingly to us, it is much easier to maintain multiple tenants this way, because we can invoke, for example, parallel migrations for some common object or similar objects between tenants. From the other hand, there are as you may know, there are no cross-database queries in Postgres itself. I'm more than sure that every Postgres user have seen this error. And yeah, we'll work around it using the building extension, usual story here. But more importantly, such approach is poorly supported by Citus itself. Because one database with Citus requires daemon process on both machines. It requires n connections, where n is number of workers in cluster for deadlock detection, and 2 connections for transaction recovery purposes. Now, let's assume that we have a cluster with 40 machines and 30 databases on these machines, workers. Doing a little math, we get 1,260 connections only for maintenance purposes per worker. 60 of them are required each minute by default, and 1,200 just stay idle all the time. What did we do to battle that is disabled automatic recovery and deadlock detection, and scheduled sequential invocation on all databases ourselves. Luckily, Citus provides us with the functions to invoke both of that manually. but it will not solve all your problems. There are still issues with that. Another point of pain in our maintenance process is multi-level mat views. So consider a scenario where you have mat view that depend on another mat views, and you will have to obviously to schedule the refreshes in a strict succession. What's wrong with that? Well, you will have to pick time of refresh carefully and manually, and you are at risk to get stale data if there are delays of refreshes somewhere in the chain. So what we do to counter that? We implemented a simple event-based solution, neatly integrated with our ETL middleware to essentially configure triggers. And now our views are refreshed on triggers, not database triggers, but conceptually triggers when their dependents are ready. What we got is got rid of all cron expressions. Now all the objects are updated automatically, and we do not get stale data. Refreshes may be delayed, but data will always be fresh in those chain. And as nice side effect, we get data to create a fancy actualization dashboard to see the state of refreshes for our views. Now let's talk rebalancing here. Very important part for a distributed database, of course. I once again remind you that it got much easier in recent years. Hooray, and thank you, Microsoft and Citus. But there are some minor issues with that. Minor. First one is, well, issues. Not all edge cases covered with that process. There may be some issues that you will have to deal with it. But more importantly, default rebalancing leads to underutilization of a cluster. How so? Let's consider the situation when we have 2 workers with 4 CPUs and 4 shards per worker. Now we add 2 new machines to that cluster and invoke a rebalance. After that, we will get 2 shards per machine. As you may see, 2 is less than 4. So 2 shards clearly lead to the underutilization of our newly rebalanced cluster. Instead of rebalancing, you can do alter distributed table and change the shard count of the table in question. That way, it will work as expected. You'll get a nice layout of shards according to the number of CPUs, but there are some considerable drawbacks with this approach. First, there is no convenient start function like with default rebalancing that was open sourced. You will have to alter each table that you want to alter manually by name. And what's more important, when table shard count is altered, it is recreated. So you will get a new table with new OID after alteration. And as you may suggest, it means that you will have to recreate all dependent object views, indexes, etc. Citus tries to do that, but unfortunately, there are issues with that as well. Now, at time, if you want to know more about our issues with FACE and how our practices and conventions, there's a series of posts on the zone where I describe that in much more detail. Now let's talk user experience that users have with our system. Let's talk expectations. We expected our users to have frequent queries with reasonably small results. So all the substantial aggregation will be performed at DB level. Unfortunately, in reality, our users perform 1 query per day, very slow query, which loads like gigabytes data of size. Why so? Well, essentially because BI tools encourage this. So, for example, common Tableau BI tool encourages users of extracts. Data science users are used to Pandas library or NumPy with their statistical API. So, as a general rule, it is common practice for data science users to perform their data science tasks on a CSV file or something like that. So what we get as a result is user don't care about slow queries and why they, if they run it once a day, and they write an efficient SQL that harms them and harms other users of the system. What we can do with that is educate our users, tell them how to write efficient SQL, especially in Citus, impose some restrictions. There are statement timeouts, obviously, and there is also neat extension to Postgres to prevent users to override these statement timeouts. But you can also go even further and implement some sophisticated procedure to kill such problematic queries. For those who try to work around those workarounds. And you should obviously monitor how users use your analytical warehouse. Let's see, it's another topic. Let's see how we do that. From our experience, there are two primary metrics to monitor. First one is the memory consumption of queries. Here you can see our Grafana dashboard of memory consumption per PID and per query within that PID. And we collected using just PostgreSQL activity and PS tool. Nothing unusual here. It is a little bit outdated because it does not use global PID yet, but we are working on it. And query execution times, you already seen that nice graphic. It is based on PostgreSQL statement extension, but we also collect slow queries directly from server logs via copy statement. Sometimes it is a killer feature. Now, what optimization do we have for users to suggest? For Citus users should look out for distributed subplans in their queries. It happens when you try to join distributed tables without usage of distribution columns using CT, for example. It will lead to distributed subplan in the query plan. And essentially what it means is that Citus will have to pull all the rows from CTE to coordinator and then redistributing them back to workers. By default, this is called intermediate result, and by default it is 1 gigabyte in size. But as you can guess, it still harms the performance tremendously. So if you see this in your query plans, you will need to either rewrite the query or redistribute your data. Now, I haven't mentioned that, but our data is partitioned, and it is also a source of errors because we found out that if you apply some transformation to partition column, the Postgres will not use the partition pruning, and your query performance will suffer. So just leave the partition column alone. And indexes, well, default advice: if you have some slow queries, just create indexes if they can be useful. So, okay, now to conclusion. Here is the top wanted features to make our solution near ideal. Obviously, it will be just on BSS statistics. Obviously, I would like to have multi-level schemas instead of databases. So cross-database reference will be resolved essentially. From Citus, I would like to have sub-partitions because currently it is not possible to create a partition of partition, unfortunately. And distributed math views. I assume I already described in colors why I would like to have that. And as final thoughts, Citus is a great partition, great extension for Postgres. It delivers exactly what is promised in docs and landing site, but it is extension. So you should be prepared that there are some edge cases uncovered, there are some integration issues, etc. So every common issue for extension, not a core product. So you can find this presentation here on speaker deck, sorry. And I am ready for your questions here and on Discord after the talk.
Howdy, howdy. That was pretty interesting. A flashback to so many times I've written things like monitoring and custom implementations like that. It's really good. Go ahead, Claire.
I was really excited when you said when you accepted the talk, when you submitted the proposal, when you said you were able to give a live stream version of the talk, not just an on-demand talk, because it's always fun for me to hear how people are using Citus in the real world, in the wild.
Oh yeah, it was my pleasure because I wanted to let it out from my chest for so many years. And this is just the tip of the iceberg, actually, because there is so much more.
Yeah, I was going to say, so I noticed on your slide, so you said 2017, like that. I mean, that's the before times of so many things. What was the first version that you deployed this on with Citus?
I assume 7.0.
7.0. Okay, so that's way back.
Citus 7.0.
Yeah, that's
Citus 7.0. Yeah,
Citus 7.0. So that's way back. You must have been ecstatic when Microsoft like fully open sourced Citus, after the purchase and all that.
You have no idea how tremendous that was for us. It was like our local celebration.
Yeah, and I imagine, because I've run local Citus before for folks, and the shard rebalancer to me was also like one of the key pieces that, like, once that was put out there, like it was kind of a game changer for people who wanted to do Citus.
Well, once again, as I said in the presentation, it's not a silver bullet. It has its own issues, but yeah, still it is so much easier now.
So for people who are just joining, I just want to clarify, Citus, the extension, did go open source back in 2016 when it was first unforked, right, and became a Postgres extension. But there were a few enterprise features that were not open source at that point. So the going fully open source, that was, 2021?
Is
that right?
Yeah. I remember that day.
I remember that day. There you go. Put it on the calendar. All right. Well, thank you so much. I think there are some more questions in the Discord, as those things tend to do. But once again, thanks for speaking, and it was fantastic.
Thank you for hosting me. Yeah. Thank you.
Thank you so much, Ivan. Ciao, ciao. We'll see you on the Discord.
Yeah, obviously. Yep. Bye.
All right. And who do we have up next?
Pamela Fox. Welcome.
Hello.
Howdy.
Hey, Pamela.
Hi.
So, Pamela is a cloud advocate in the Python team at Microsoft. And you're here to give us a talk today about using Postgres on Azure using Bicep.
So for those of us who are not at Microsoft, the title Cloud Advocate sounds a little ephemeral or something. Can you explain what that actually does? What do you actually do?
Yeah, so my job is like to advocate on behalf of Python developers for the cloud. You could also think of it as advocating on behalf of Microsoft. I guess we kind of advocate on both fronts, but I think it is trying to help Python developers be successful with Azure. So whether that's, using the Azure SDK or hosting things on Azure, all the things that you can do with Azure. So trying to make it easier for Python developers, because I'm a Python developer and I want it to be better for them.
Well, and as I've been getting to know you, Pamela, it seems like you've been involved in helping people understand technology and understand how to solve problems for a while. Like you worked at Khan Academy, didn't you?
Yeah, I created the computer programming curriculum for Khan Academy.
Wow.
Which was everything but Python. So it was JavaScript, HTML, CSS, and SQL. So I did, that was actually the first time I taught SQL was for Khan Academy. And it was very fun to get into SQL.
Awesome.
Well, without further ado, I think you should dive into your talk. Let's go.
All right. Well, hi, everyone. So since my job is to make Azure better for Python devs and Python devs love Postgres, I've been deploying hundreds of Postgres servers, for the last year or so that I've been at Microsoft. And I fell in love with using Bicep to deploy them. So I want to share that love with all of you. So my talk is for anyone who deploys Postgres servers to Azure, or anyone who's just generally interested in using infrastructure as code as a deployment mechanism, for any platform. So let's get into it. So we're going to talk about using Bicep to deploy Postgres servers to Azure. So just want to start off with clarification because there are multiple managed services for Postgres on Azure. There's the Azure Database for Postgres single server. That was Microsoft's original offering. It's no longer recommended for new apps. So I basically just never never look at it. What they introduced since then is Azure Database for Postgres Flexible Server. And this one is another fully managed service, but it offers vertical scaling, and it also stays up to date with the latest Postgres versions. And there is also Azure Cosmos DB for Postgres, which is Citus. So it's a distributed database using Postgres and the Citus extension, and that can scale horizontally, as you may know if you're watching Citus Con. I'm going to be focusing today on the flexible server offering. And, part of that is just due to what was available when I started Microsoft, but it's also just a good fit for what Python developers tend to use. But everything I'm talking about today should be fairly applicable to the Cosmos DB for Postgres offering as well. And if you're interested in trying to figure out the difference between them, there's some, links there that you can read more. So there are many ways to deploy a Postgres server to Azure, and I have experimented with all those ways, and that's how I came to realize which I like and don't like. So, let's look at those ways. One way is to use the Azure portal, and that's where you go to portal.azure.com, you create your free Azure account, create a subscription, and then you say, okay, I want to create a flexible server. So then that's going to pop up this nice user interface with a form. And one thing that I do really like about the portal is it does do this estimated cost. That is really cool. I would love to have that from the command line, and I've been asking the product teams about that. So that to me is one of the best reasons for using the portal. So the nice thing about using the portal is that you've got this UI here, and it's really easy to get started, and you just have to fill in some blanks, and you get this cost estimate as well. But it's also difficult to replicate. So once I've made something in the portal, and then I want to make another similar thing, I have to remember, like, wait, what did I enter in that box? I can't really remember what I put in there. So I don't tend to use it once I've used it once, I don't tend to use it again. Another option is using the CLIs. So there's the Azure CLI and then Azure PowerShell. So I have used the Azure CLI quite a bit. It is nice because it can do pretty much everything you might want to do on Azure. It can do, so here we have a command to create a flexible server in a given location with a given name, with this particular SKU, and an admin user and password. And that will go ahead and create that Postgres server. So, the nice thing about command line options is that we can replicate them. Okay, so I can say, hey, colleague, here's the command that I used to create the server. If you want to create a similar server, use this command. However, one thing that's not as nice is that updating a server after the fact, I actually have to use a different command for updating. So now if I start to make updates, now I have to, cobble together this sequence of command that I used and or put it together, back into an original command. So it's definitely much better than the portal in terms of replicability, but it still is difficult to maintain, right? So I'm looking like, what can I maintain? What can I come back to 6 months from now and it'll just work? So that brings me to ARM templates, and this is something that Azure has had for a while. And these are JSON files that just declaratively describe the resources that we want to create. This is just a snippet of the file, not the whole file. But he's using JSON and saying, like, okay, the type of resource we're making is a flexible server. We're using this version of the API. This is going to be the name of it. This is the location. This is the SKU. And then we continue on with specifying the properties of that Postgres server. So the nice thing about this is that everything is declared there, and it is something we can repeat, and we can share ARM templates with other people. So if you say, oh, you want to deploy the same server, here you go. And then if I come back to my project later, I could just use that ARM template and I'd be able to deploy it. The annoying thing is it's JSON. I love JSON as much as the next former JavaScript programmer, but it is JSON, and JSON is not a full programming language. It's just a JavaScript object, and it can be hard to actually use JSON to describe everything we might want to do, and to to, it's not a programming language, so we can't conditionally create some properties based on some aspect of the environment, right? A very common thing is to have, a different staging environment than your production environment. So your production environment might use a general purpose Postgres server, and this staging and dev environment might use a burstable server, which is much cheaper. And, based on those parameters, you want to be able to say like, okay, we're going to deploy this mostly the same, except change a few things based on the environment. And that can be difficult to do in just a JSON file. So that brings us to Bicep. So Bicep is, the solution to this. And Bicep is it's a declarative language, or it's also, we call it a domain-specific language. It's specifically for deploying resources to Azure. You can also call it an infrastructure as code language. So the idea is that you're describing your infrastructure as code. It's very similar to Terraform, and Terraform's the one that most people are familiar with, because you can use Terraform across all cloud providers. You can use Terraform on Azure as well. So if you do prefer Terraform, you can, probably use some of the learnings from this talk, but use it for Terraform instead. I do prefer to use Bicep because it is targeted for Azure, so it just tends to be a bit easier, and we know it's going to be up to date with Azure, and it's got a lot of tooling that's really helps you when you're an Azure developer. But Terraform is also a possibility and would have a lot of the benefits here. So this is an infrastructure as code language. We're going to declare what it is that we're creating, and then deploy based on that. So here you can say, okay, we're creating a server. This is the name of server, location, SKU. Here are the properties. So this is the entire Bicep for the Postgres server. And this is kind of the minimal Bicep that you would need to deploy a Postgres server. So how do we actually use this Bicep? Oh, well, first, let's talk about the fact that the Bicep is actually, almost a full-featured language. So it's not just like JSON. It also has parameters, types, logic, loops, functions, modules, and that's where you get really nice ability to refactor things and pass things into different modules. So we're going to see examples of most of these throughout the talk, so you can see how it really helps the fact that Bicep does have all these features of a language. All right, so let's look at a parameterized Bicep file. So this is one of the features I was talking about, parameters. So this is really nice because I was saying you might have multiple environments, a dev environment, a prod environment, and you could use parameters for values that vary between those environments. So here I have a parameter for the server name, right? Because we're probably going to want a different server name for those two environments. A location. You might use different locations. Like you might have a production location that's closer to your customers and a dev environment that's closer to your devs. Here I also have a param for the admin password. And you notice also I use something called a decorator. So there's these decorators that you can add to parameters in order to constrain them. And so here I'm using the @secure decorator. So that way Bicep knows, hey, this is supposed to be a secure parameter. So don't be, like logging this and, make sure that this is actually, protected to some extent. So you should definitely be using secure parameters for things like passwords. But you also should go above and beyond for things like passwords. So we'll talk more about that. Yeah, so there we go, using params. So this is a nice starter file. And now how do I actually use this file? So there is a command in the Azure CLI, which is az deployment group create. And I tell it what resource group is going to deploy the Bicep resource to, and I give it the template file. So I say, okay, you're going to deploy to this resource group. Here's the file. So I give it that Bicep file that we just saw, and it prompts for any parameters that haven't been specified. So here, since I didn't specify admin password, it's prompting me for it. So I'm just going to type it in. You can also store passwords in a file. You could fetch them from a key vault. So you have various options for how to pass parameters in, but here I'm just going to type it in and not show you. And then so it'll go off and it'll create that Postgres server. And it does take a few minutes because it's, it's literally allocating some space for you in the cloud. And carving that out for you. And Postgres servers, I do find take a little bit longer time to create than some of the other Azure resources I create. So it could take a few minutes. And then it comes back, and what it comes back with is actually a bunch of JSON. So we're back to JSON again, right? It shows you a JSON output of everything that got created. And you can look through that output to, see properties of it. But typically what I do is I just go to the portal and I look at it. You can also specify parameters on the command line. That's another way of specifying parameters. So once it deploys, I like to go to the portal, just check everything out, make sure it is looking good. So I can go in the portal and see, okay, yeah, it's here. It's got the right server name. It's got everything expected. I mean, it works. So we don't really have to double check in the portal, but it's nice to see that it's there, and you can poke around at it from the portal. Okay, so now let's go more into what we can do with Bicep so that we can customize this Postgres server more, because that was basically the minimal Postgres server, but there's a lot more that we might want to do with it. So for the rest of what we want to do, I'm going to use child resources. So these are resources that only exist in the scope of a parent resource in a Bicep file. So for Postgres, we can make child resources for declaring the administrators, configurations, databases, firewall rules, and migrations. So let's take a look at making a database. So by default, Azure Postgres flexible servers, they have a database called Postgres, and they have system databases named Azure Maintenance and Azure CIS. So every flexible server will have those databases. But you may want to have a different database. You might want to have a database with a different name. So what you can do is create a child resource underneath, inside your Postgres server resource in the Bicep file. So you can see that, here we start with the Postgres server, and then nested inside that, we have a database resource, and we give that a name, Wed Apr, and that's all we need to do for a database child resource. So now when we deploy this, it's actually going to create that database as well as the default ones. We can get a little fancier if we want to have multiple databases. So I'm going to make a param that's an array, and the array is going to have the names for each of the databases. So we have Wed Apr and analytics, and then I can use a for loop to create multiple child resources. And it has this syntax you see here where you say, equals, and then the brackets and the for loop there. And that way I'm actually creating multiple child resources. So this is a really common use of arrays and for loops, is to make multiple child resources. And we'll see this come up again soon. So hopefully you're starting to see some of the advantages of really having more of language features inside Bicep. So once we've done that and deployed this Postgres server that has databases, we could go to the portal, we could click on databases, and now we see that the additional 2 databases are in there, analytics and Wed Apr. And we also see we can connect to those databases. So that's something cool you can do, is you can actually connect to the databases inside the portal and tinker with them there. Next, we can make firewall rules. Okay, so by default, you need to figure out when you're deploying a Postgres server what your networking story is going to be. The default is that it's publicly accessible, but it's not accessible to any particular IP, so it's not really publicly accessible. So you need to explicitly tell it what IPs you're going to allow it to be accessible from, or explicitly tell it not to be accessible to any IPs. So in this case, we're going to create a child resource of firewall rules and tell it to allow Azure internal IPs. And the way we do that is say the start IP address is 0.0.00. Might have too many zeros there. And then the end IP address is the same. And this will allow any Azure resource to be able to contact that Postgres server. And you have to keep in mind, that's going to mean any of your Azure resources, also anybody else's Azure resources. So, there's a bit of a security hole here. If there's, someone, God forbid, that's doing something nefarious on Azure and who manages to figure out your username password, they are going to be able to access it from their Azure resource. So we will talk about using a VNet, which is a better approach. But this is a decent approach to start off with. And We can also allow our individual IPs. So if we wanted from our dev machine to be able to access the server, we can do a firewall rule just for that IP. So here I've got an array, with my IP and, my colleague's IP, and I say, okay, let all these IPs in here. So this is a common setup to allow Azure IPs plus some individual IPs. And you do really need to keep in mind the security implications of doing that. And once we do that, we can check the portal, and what you'll see, what it looks like in the networking tab is that it says the connectivity method is public access, and that it's going to allow public access from any Azure service within Azure to the server. And then it's also going to allow those individual IPs. So that's what it looks like after deploying that bicep file. All right, so yeah, let's talk about making it more secure by injecting the Postgres server inside a virtual network, with whatever it wants to communicate with it. So with a Python web app, right? And it's a Python web app, Postgres server, they can chill in the VNet. So how do we do that in bicep? This is where we're going to get a lot bigger with our bicep because we do need to create multiple resources. So we're going to have to make a virtual network. So an Azure virtual network, an Azure private DNS zone, and then also whatever resource actually needs to access the Postgres server. So in this example, I'm doing an app service web app, but you could have Azure container app, an Azure function, a VM, whatever it is that needs access is going to want to live inside that VNet as well. So the first thing we do is create that VNet with we have to tell it, its possible private address space. So I gave it a range there using the CIDR notation. And then next I create subnets inside that VNet, and I delegate ranges within that original address space. I delegate ranges to particular types of Azure services. So here I'm saying that this range gets delegated to flexible servers. So that's they're going to get, live in that part of the VNet. And then I also need a subnet for the other resource. So in that case, I said server farms, which is actually app service web apps. So I said, okay, this other range, non-overlapping range, is going to be delegated to these server farms. And now in order to let the other service, so my app service web app is going to be publicly accessible. So it doesn't need a private DNS, right? Because I'm going to let anyone hit that up, right? No problem. But I don't want my Postgres server to be public accessible. But I do want to be able to access it via a URL instead of an IP. So what I do is create a private DNS zone. And the name, there's some naming rules here. So the name has to end in postgres.database.azure.com. So you see that on the second line. But it can't be the exact same as the database. So here I have .private.postgres.database.azure.com. And that satisfies the naming rules for this private DNS zone. And there's more information in the links on this slide because it is a little tricky. So I create this private DNS zone, and then I link it to the virtual network. And that is what's going to allow the web app to be able to use the URL to actually interact with the server, despite the fact that the Postgres server isn't technically accessible at that URL. Azure will be able to look up and realize that there's a private DNS that's doing a mapping to a VNet instead. Now I need to configure both the resources so that they know about the VNet, so they get injected into the VNet, as it's called. So I add on the Postgres server, I add a network property, and I add there the delegated subnet resource ID. So I get that from the virtual network object, resource that was made before. And then I also have the private DNS zone ARM resource ID. And so that's what's linking it to the private DNS zone. So that Postgres server has to get connected to both these things, both the VNet and the private DNS. But then the web app only needs to be connected to the VNet. So it gets connected to the, with the subnet resource ID as well. In this case, using a child resource. All right. So now we have all the pieces, and there's a lot of pieces here. And I'm providing all this code will be accessible afterwards. So you're welcome to just take it if this is the thing you're trying to do. So altogether, you end up with a fairly long file that has all these resources in it. and you'll be able to follow the links in these slides when I share them at the end. But altogether, you're going to have the file with all those resources, and also have the web app declared in there, and then you can we can deploy that using the same command as before. So once we deploy it, we can check the portal, and now we see we've got 4 resources deployed, right? The Postgres server, which I left out of that screenshot, but we'll have a Postgres server, we'll have the app service, we'll have the virtual network, we'll have a private DNS zone. We also have an app service plan for the app service. So you end up having a bunch of resources. A VNet is a best practice from a security perspective. It is a little more complicated to set up. Luckily, I've done the work for you for the most part. So you can, take that work. It also can cost a little bit more. So you can look at the costs for private DNS zone and virtual network to see if it's reasonable for you to use that as a security mechanism. But it is definitely recommended from a security perspective. Okay, so let's talk about tips and tricks for writing bicep. I've been writing quite a lot of bicep over the last 8 months, and I guess I've gotten a reputation as the bicep person on my team, or at least the one that loves bicep. So let's talk about some tips here. So with PostgreSQL, I showed username, password. I showed VNet. There are other things to consider for security. So one thing that's more secure approach than username, password is to use managed identity. And so managed identity is you give an identity to your Azure server, and you say it's a system assigned identity, and then it's allowed to, it kind of like creates username passwords on demand. It generates these tokens and uses that instead. So it's nice because you don't have to do secret rotation. It's kind of doing that for you. So managed identity is generally a best practice. It can be a little trickier to do in Bicep. I did recently work on a sample that uses both Bicep and the Azure CLI in order to do a Postgres with managed identity. So if you're interested in that, check out that sample. The ultimate is managed identity inside of VNet, and I think my colleague Aaron is going to be working on that. Location. So the biggest problem I've had with deploying Postgres servers is location constraints. And this is actually mostly because I'm a Microsoft employee. So Microsoft employees do have different location constraints than public folks. So hopefully you all won't run into this, but as a Microsoft employee, if you do run into an error, it might be because you're not permitted to deploy Postgres in that location. And in that case, you should change your location. For example, East US 2, Microsoft employees can't provision in that for Postgres. Hopefully, if you're not a Microsoft employee, you're just not going to run into that. The good thing is we're keeping things more free for the the non-Microsoft employees out there. So it's better for you. Another good thing to keep in mind is that, with Bicep, one of the cool things is you think with Bicep, like, oh, okay, I need to change my server configuration. I'm just going to change my Bicep and, redeploy it. You can't always change everything. Postgres actually has a number of constraints in terms of what can't be changed. So you can't change the admin username. Once it's set, it's set. You can change the password, which is good, but you can't change the admin username. You can't change the PostgreSQL version. So if you did want to update to Postgres 14, you would need to, go through the process of doing a database backup and a restore to a new server. The nice thing is that you could, just copy and paste your Bicep, and now you've got a very similar server. You don't even have to really copy paste, just change the parameter. You can't change the location. You can't change the networking option. So you should decide from the get-go is, do you want to go VNet or do you want to go public? So yeah, in theory with Bicep, with most things most resources that I use with Bicep, you can change things after the fact, but Postgres does have a number of constraints about what can't be changed. So you do some experimentation and be confident about your setup before. All right, other tips. Bicep, the Bicep team really wants to make it a nice experience to write Bicep. So they've developed an extension for VS Code, which is, a very popular IDE. It comes from Microsoft. And this extension has syntax highlighting, it has snippets, it has autocomplete, it has linting. So I really like to use it for the linting personally. I know other people really like to use it for the snippets. I'm just not a snippets girl. But it's super helpful. So definitely, if you are a VS Code user, install that extension. You can also do linting at the command line, right? So you can get linting in that extension, or you can do it in the command line. So you can use az bicep build-f, and you give it the path to the file to lint, and it will go and it'll check it for errors. And a really good practice is to use a CI/CD workflow in order to always check for errors. So in all of my repos where I have bicep, I have this GitHub action workflow that attempts to run the build command, and if there are errors, it will fail, and I'll get told. Something even more interesting is to not just look for errors, but look for security issues, right? So you could have a bicep file and it's technically valid bicep, but maybe, it's using, username and password, when a better approach is to use managed identity. So there's this new action, this Microsoft Security DevOps action that can analyze templates, and it will let you know about all these potential security errors in your templates. So we've started to add this. It's very new. So we have started to add this to our repos. I have it in a few of them. And just working through some issues because we have very complicated bicep in some of ours. But the cool thing is, like, once you do it, you're going to get this workflow, and it'll error. It can error out if you want it to error out, and it'll say, like, okay, on this line, you're doing this thing where you're using a password. It would be better if you use managed identity instead. So you can either have the workflow, break when that happens, or you can upload those errors to your code quality tab in GitHub or in Azure DevOps or whatever, and then you'd be able to monitor them as security issues for your repo. So this is another really nice thing to do, because we don't want just to have correct bicep. We want to have secure bicep. You want to have secure, Azure resources. So I love, in the age of, Copilot and ChatGPT, I love linters. So any sort of linting I can do, I will do it, because I want to have the confidence that what I'm creating is going to be really successful. Now, another thing you could do is, I've showed Postgres. I use bicep just to make Postgres. But of course, you can use bicep to create all of your Azure resources. And most of the time, that's what you're going to do, right? You're going to be making, your VMs and apps and all that stuff. So when I do that, I like to use the Azure Developer CLI. This is a new CLI tool to take care of the entire deployment workflow. So it requires, bicep files. It also requires another YAML file, a few other things, and it will make it super easy to both create all your resources, but also bundle up your code and send it to the server. So that's the part I love of it, is that it's going to, create all my resources in Azure, and then, it'll bundle up my container app and, Docker build and send that to the cloud, or it'll zip up my app code and bundle and send that to the cloud. So I love to use the Azure Developer CLI to take care of everything. It also does CI/CD. It does monitoring. It does a lot. So this is a new CLI. Different from the Azure CLI. It's the Azure Developer CLI, but it's really, really cool. And I've made 15 templates for it in the last, 4 months, because I love it so much. And so you can find app templates that use Postgres in the AZD templates gallery. So there's a link here, and it's, I just already filtered it by Postgres for you. So if you want to find examples of full applications with, their entire bicep files written, you can look in that AZD templates gallery and just start from those existing ones. I have written mostly Python ones because, that's my thing. But in terms of the infrastructure shouldn't be that difference between Python and another language like Rust or Go or whatever. So you should be able to take the infra files that I've already written for a particular, resource architecture, and then use them for whatever language you're using. And yeah, then finally, some more bicep writing tips, because I do hear a lot that people don't like to write bicep. And, it's a new language, because it's always hard when you're, writing a new language. So I always like to keep the bicep reference open. So I'll look up whatever I'm currently working on, right? So the PostgreSQL Flexible Servers bicep reference, it has all the properties listed out. So I'll just always have that open in a tab just to look at. And it also has examples at the bottom of each page. And it does also have examples in both ARM and Terraform. So if you watch this, but just, determine you still want to use Terraform, you can use that, the same reference has Terraform as well. You can search GitHub for examples using lang bicep. I use GitHub code search all the time to help me figure out how to do something new. And so I love to search for, for examples using lang bicep. So I'll do like lang : bicep, and then whatever particular thing I'm looking for. Like I've searched for VNet before, just the name of the resource, and I can look at other examples, see, oh, is somebody doing something similar to what I'm looking for? So I think that's a great thing to do for whatever sort of new code you're trying to write. Another thing you can do is that you can export ARM templates from the portal. So if you did use, the portal UI to create a resource and it exists in the portal and you're trying to figure out how to use Bicep for it, you can go to the portal and you can go on the bottom to like templates and you click like export template and you'll get the ARM JSON. And then you can use AZ Bicep decompile to turn that into Bicep. And then you can start from there. The thing to know about that is that it creates a ton. Like the ARM JSONs there will have every possible configuration. You don't need all of it. So a lot of times I'll like look at it to see, what is in here, and then I cut it down because you don't need it all. You just need the minimal, override configuration. And I also have a blog post that talks about this more, so you can read that blog post for more Bicep writing tips. All right, so this is what I wanted to share with you today. So thank you for watching. I hope you've learned some Bicep and that, maybe you want to try it out yourself. You can grab the slides at this aka.ms/postgres-bicep.slides. And you can follow all the links in the slides so that you can take all of the Bicep code and hopefully make it easier for you to get started with Bicep. And you can tweet at me or GitHub at me or whatever, Discord at me. I'll be in the Discord after as well to let me know about your experience with Bicep. And if you're looking for any particular examples, I'm always looking for excuses to, try something out. So yeah, thank you for coming today. That is my talk.
Excellent. I have to say, that was really great. I learned quite a bit about Bicep. I did not really know that much about Bicep. It seems like it is one of these I guess next generation, like you said, like Terraform or like Pulumi. So it kind of falls in that category. So that was really good. I know we're a bit up on the clock, but I did want to ask you a quick question. Like if I'm deploying Postgres, I'm probably going to be needing to deploy PG Bouncer with it. Is that easy or is that difficult if I want to do that with Bicep?
Well, in Azure, PG Bouncer is enabled by default on the Postgres server. So you just got it.
On Azure Database for Postgres, you mean on Flex Server?
Cool. Yeah, sorry, to be very specific, the one that I showed is enabled by default. Do you know about with Citus?
I imagine it must work pretty similarly then. Yeah, so it sounds like it'd be pretty easy.
Yeah. Certainly
Excellent.
For the ones I showed, it's just already enabled, and you can go into server parameters in the portal to look at all those settings, but it's already enabled.
Okay.
Well,
cool.
And I know Yalta's on the Discord chat, and he's both on the Citus project and a PG Bouncer maintainer. So if anybody has any questions about that, they can definitely pop them in on the Discord. Pamela, thank you so much for being part of Citus Con today. I also learned something about the naming of Bicep and that there's a connection between Bicep and ARM.
Yeah.
I didn't actually connect those dots beforehand. So yeah.
Yeah, I literally only connected them this morning. So don't worry.
All right. Well, thank you so much for being here. Appreciate it. And you're going to go to the Discord to answer questions and chit chat. All right. Awesome.
Excellent. All right. And with that, let us then bring in Melanie Plegaman. She is helping us sort of round out our third period of the show today. So excellent. How you doing?
Good. How are you?
I'm doing well. It's been good so far.
For people who don't know Melanie, Melanie is a senior software engineer at Microsoft, and she's a Postgres hacker and Postgres contributor.
And just for those who don't pay attention to the Postgres commits, which maybe is a larger number of people than you might expect, she recently contributed pgstat.io into Postgres 16. Fingers crossed that will be available later this year. And I guess that's a big part of what you're going to talk about today.
Yep, it is.
Observability in Postgres. And I know people are really excited about pgstat.io, so let's find out why. Take it away, Melanie.
Yeah, so this talk is going to be great for users that are already comfortable doing some amount of tuning and want to kind of take it to the next level. And so that's really who it's targeted at. So I'm going to talk about the difference between sort of the existing I/O statistics that are available in Postgres and what pgstat.io can offer in terms of observability. Just about me, I'm a Postgres hacker working at Microsoft on the open source Postgres team. The last 2 years, I've been very focused on I/O performance and I/O benchmarking, but before that, I've worked on a lot of the other subsystems in Postgres, like Planner and Executor and things like that. So users have pretty much two main goals for their transactional workload I/O performance. They care about throughput and they care about latency, right? So you want high TPS and low latency, low tail latency. That's when you're thinking about performance, those are the things that really matter. You can boil everything down to that. But some of the impediments to that, the most sort of obvious one is if your data is not in shared buffers. So if your data is either too large for shared buffers and you don't expect it to fit, or you've misconfigured shared buffers, then you're going to see more I/O, and that can be a common performance issue, the cause of common performance issue. Another one is issues around wall I/O and checkpointer misconfiguration. That's a pretty common reason that people are seeing I/O bottlenecks. And then auto vacuum. Tuning auto vacuum is notoriously finicky, and it really depends on your workload, and the out of the box settings are going to be good for no one, basically. So, if your auto vacuum's not running frequently enough, if you're not, if there's, the workers aren't being aggressive enough, that kind of thing. So as we think about tuning, these kind of are bucketed into different areas. So you can tune shared buffers. There are different Postgres SCUCs around the background writer, around checkpointer and wall tuning, and around auto vacuum. I'm not going to get too much into checkpointer and auto vacuum. I'm primarily going to focus on what sort of data we can use to indicate if we need to make a change to shared buffers or to background writer configuration. And as we think about tuning, the ideal is that you're data-driven. So you want to base tuning decisions on actually what's happening in the database. And so how do you get that information? So one option is to use operating system statistics and utilities, so like using IOStat and other, there's different extensions in Postgres that'll give you access to some operating system information about IO. But the first place, the most obvious place that you would go is the existing IO statistics in Postgres. So pgstat database is going to give you per database statistics on reads and writes, hits and, read and write time, hits and reads. There's pgstat.io all tables and indexes. There's pgstat bgwriter, and then many, many users are using the pgstat statements extension, which is going to give you a fair amount of information. But we wanted to add pgstat.io because there's actually substantial gaps in these existing IO statistics that are in Postgres, and even those that are in extensions. And so what we really needed to do was actually make changes to where we're collecting statistics, and not just what we're revealing and bubbling up, but actually what are we actually collecting. And so we focused, I think you can kind of think of the three areas or the three gaps that pgstat.io is addressing, and we can kind of break those down. So I think one of the most important ones is that in all of the existing IO statistics, writes include flushes and extends. And I'm going to talk a little bit more about, okay, what is that anyway? And why does it matter? Another sort of the granularity is one of the main problems with the existing IO statistics. So all backend types, whether that's checkpointer, background writer, whatever type of backend it is, those are all going to be included in the same statistics. You're not going to see it broken down. There's some amount of, there's some exceptions to that, but largely you're going to see it all together. And then also you're going to see IO for all different contexts. In context here, What I mean is, okay, vacuuming is different than just normal transactional workload IO. Doing a bulk read, doing bulk data loading, that's different, sort of a different IO pattern, a different reason for doing IO. And so you're going to want to address that differently when it comes to tuning. So this is just a snapshot, probably right after a little bit after I did a NitDB, so you can see a lot of it's 0, but this is what pgstat.io looks like. And you can see that we actually have read and write and fsync time. So that's cool. We can see the timing. And then we have some specific columns that are actually relevant for buffer access strategies, which I'll talk about a little bit later, like reuses. So that's just to give you a little picture of it. So let's go back to what I said about what are the gaps, right? So why do we care about counting flushes and extends separately? What is a flush? So in pgstat.io, we call flushes writes because we're able to distinguish writes from extends. And in order to kind of talk about this, what I want to do is walk you through from an internals perspective, the update or insert, some of the steps are pretty similar workflow in Postgres to give you an idea of like, what is different about an extend and why does it matter if it's separate and what does that tell us? So when you are, let's say you're going to just do an insert some data, first you have to find a place to put it. So your file for your relation is going to have, blocks in it. And so you need to find a block that has some space available. And so that could be in the middle, it could be at the end. You're just looking for a block that has space for that data you're going to add. And if there isn't a block that already has space, you're going to need to extend the file to add another block to the file. And if you think about it, I mean, this is inevitable. You can't avoid this. If you have more data, eventually you're going to have to make the file bigger, right? So now that you've sort of identified which block you want to actually, in the file, you want to actually add your data to, you have to get it into shared buffers. So first you'll check, okay, is it already in shared buffers? If it's already in shared buffers, that's a cache hit, right? A shared buffers hit, and we're done. So that counts as a hit. We need to do the read, and we can just add our data. However, if the block is not already in shared buffers, then we need to find a shared buffer to put it in. And the shared buffer that, in order to find a shared buffer to put it in, we might find one, and then actually that shared buffer is dirty. It has unrelated data in it that is not necessarily data from our table, but we can't just throw it away because then we would lose the data. So before we can use that buffer, we have to write that data out. And that's a flush. And that will count as a write in pgstat.io. And you can see that here, if that buffer had already been free or clean, that it hadn't had dirty data in it, then we wouldn't have needed to do this write. So it's an avoidable write. Finally, we're going to read our block into the shared buffer. And now we have it and we can do our insert. And this write is not a write like, oh, it's a write out to even to kernel buffers or disk. This is just basically copying in our dirty data, our tuple, into that buffer. So what does this tell us about why it's important to count flushes and extends separately? What we saw was that the flush of the dirty data from an unrelated source was actually avoidable. If we had had a clean buffer, we wouldn't have needed to do it. Whereas the extend is something that is unavoidable. We're going to have to do extends as the file gets bigger. It's a consequence of our workload and not cleaning up someone else's mess, basically. So by separating them, we can allow ourselves to understand whether or not we actually have to tune something. We could see a lot of writes and say, oh, we probably need to increase shared buffers, but actually we're just doing a lot of extends. And this is something you might see, for example, if you're doing a bulk write, you're doing a copy from, you might see a ton of, in existing IO statistics, a ton of writes, but actually these are just copy from doing a bunch of extends. And this is not even data that's really part of your working set for your transactional workload necessarily. So tuning for that is going to be disadvantageous. I also mentioned earlier that we want to separate out I/O by the context in which it's done and by backend type. And to talk about that and why that's important, I'm going to use as an example auto vacuum I/O workflow roughly. So auto vacuum and vacuum, but let's just specifically talk about auto vacuum, is going to identify, okay, what are the blocks that I need to vacuum, and then go through and do each one. So it might not be all the blocks in the relation, of course. So it identifies the next block to vacuum, and then it has to look for it, see if it's in shared buffers. If it's in shared buffers, then it can vacuum it. And it's also, that's a cache hit, right? So we didn't have to actually do I/O. Now, this is where it gets different from the regular update insert workflow we were talking about. So if we need to actually do I/O, so we need to go out and read in the block that we're going to vacuum, we need to find a shared buffer for it. That's the same as before. But the difference here is that vacuum is going to use a buffer access strategy. And what that means is that we are going to cap the number of, or so we're going to use a ring buffer with a certain number of buffers in it. And each time we need a new buffer, we're going to go around that ring and reuse buffers we've already used to vacuum previous blocks. And what this does is it keeps us from using up all of shared buffers just to vacuum, because that'll, wash out all of our working set from shared buffers. We don't want that. And so the important thing is that when we're initially finding buffers to use, we do this lazily on demand. So we get a shared buffer, we evict it, which counts as an eviction in pgstat.io. And now we add it to the ring. Once we've filled up the ring, the next time we need a shared buffer, we're going to reuse a buffer that we've already used. And that counts as a reuse in pgstat.io. And when we reuse that buffer, we need to flush the dirty data that was there already, and we need to write out the associated wall up to the LSN that was associated with that data that we vacuumed. So what's important here is that even if there are clean shared buffers, we're not going to go and use them for that data we're vacuuming because we're using this buffer access strategy. And then what we'll do is, read the block that we're trying to vacuum to begin with into the buffer that we've selected, vacuum it, and mark the buffer dirty. So what does this mean about why pgstat.io is useful? So auto vacuum is done by auto vacuum workers. So auto vacuum worker is a different backend type than a client backend. So we're able to see that I/O pattern and that I/O that's being done by auto vacuum separately in pgstat.io. And what you saw was that we're using this buffer access strategy, which is a separate pattern and going to show up separately than normal transactional workload working set. And we may be vacuuming relations that are not part of our working set. It's not the hottest data, and that's okay. So we don't necessarily want to tune our database to accommodate what we need to vacuum. So it's okay to, vacuum older data. We don't necessarily need to resize shared buffers so that all fits in shared buffers. And similarly, context matters. So vacuum is also an I/O context, so we can kind of see that separated out. But another example of that is a bulk read. So for example, if you do a large select, which is basically a relation with where the number of blocks is, greater than shared buffers divided by 4. So if we're doing a large select, we're going to be doing a lot of reads. And that data is not necessarily part of our working set. So we don't necessarily want to resize shared buffers so that giant table can fit it. You might have a mixed workload with transactional queries alongside some type of analytical work. And so what we're trying to do is let's tune specifically for our transactional workload for that working set to fit in memory and to make that workload efficient. And then you can separately think about tuning for your analytical workload and make different considerations. If you know that a large part of your workload's not going to fit in shared buffers, you might want to actually decrease shared buffers because there are certain advantages to that. And I won't go into that more now. But now, given what I just talked about, I think it's useful to kind of take it back to pgstat.io and look at a few concrete examples and how it looks in the view. So I just mentioned that sometimes your workload is not going to fit in shared buffers. Like that's just a reality. Might not even, might not fit in memory. You have a large database. That's like pretty normal. So in that case, it might not be an option for you to increase shared buffers so that everything fits in shared buffers. But one thing that you do want to watch out for is that you still want to avoid client backends doing their own writes as much as possible. So in this example, you can see client backend normal relation writes is decently high. And we actually want that number to basically be 0 because this is not a write in the sort of the sense of insert, update, whatever. This is actually the client looking for a buffer. It can't find a clean buffer. It has to flush the data that's in that buffer. So we want client backends to be doing 0 writes. We want the checkpointer and the background writer to be taking care of this for them so that when you do a read, you're not doing a write first. So in this example, we're seeing a background writer is doing some writes, but maybe it could be doing more. So we have some options there. Background writer historically has a certain throughput cap that's relatively low. So if you have a super fast, like high throughput workload, then maybe background writer is not going to be able to help you. But you can decrease the background writer delay. You can increase background writer LRU max pages. I won't get into the specific mechanics of those gucks, but there's articles online you can look at, background writer tuning, that kind of thing. So, and then a lot of times though, like let's take this case, shared buffers is too small. A lot of people are, if you have the ability to change shared buffers, of course you need to restart and everything. A lot of times that's going to help with your IO problem. So in this example, in contrast, if you look at the number of reads for client backend in the normal context and the number of writes for client backend in normal context, there's almost 1 write for every read. So that's bad. That's a bad sign. That means most likely we are evicting and rereading in the same blocks over and over. And you see evictions as high. After the first time that we've gotten everything off the free list and we've used every buffer at least once, everything is going to be an eviction after that. So, but in this case, because we're seeing reads and writes be very proportional, that's like a hint that, hey, or a signal that it may be necessary to increase shared buffers. Our primary working set just isn't fitting. And you can see that with our cache hit ratio too. It's around 60% when we look at the client backend normal hits and reads. And just a simple cache hit ratio query for client backends doing things in the normal context with permanent relations, you can calculate the cache hit ratio this way. On the other hand, you want to avoid premature optimization. So one of the things that was really hard before pgstat.io was actually calculating your cache hit ratio if you have any sort of other types of IO than your very standard transactional workload going on. So in this example, you can see that client backend normal context reads pretty low. Looks like we read in our working set and then the hits are really high. We just keep reusing those blocks and everything seems like it's kind of going okay in terms of that. But you can tell that the number of client backend bulk reads is really high. We also have a fair number of auto vacuum reads. So what you can see there is if those were all together, if they weren't separated by backend type and context, then we would actually calculate a pretty incorrect cache hit ratio. And I'll show you what that would look like. If we used pgstat database to calculate the cache hit ratio here, we get about 45%. And that's similar to if you use pgstat.io without a where clause. But what we care about is tuning for our regular workload. So once we add in the where clause where the client is back, where the backend type is a client backend, it's in the normal context, it's a permanent no temp relations, our cache ratio is basically 99%. I mean, we definitely don't need to increase shared buffers for this. So I think pgstat.io gives you the additional information that you need to avoid these kinds of premature optimizations. So what's next for pgstat.io? So hopefully in Postgres 17, we're going to add, there's a category of missing IO that I think would be really good to add, which is all the IO that's outside of shared buffers and outside of local buffers. So things like if you do, there's certain operations like create index where it's doing a lot of IO sort of directly. We're calling it bypass IO. Also per connection IO stats, so taking pgstat.io, separating out per connection, and then integrating pgstat wall, the information that's there, into pgstat.io and sort of streamlining it so there's a single source of truth for your IO information. I will be answering questions on Discord, so I'd love to hear about your use cases, your questions, and I'm just really excited for people to use the view in Postgres 16 and tell me what they think.
That was wonderful. Thank you, Melanie, for being here. I have a question for you. For someone who's really familiar with pgstat statements, when should they think about using pgstat.io versus pgstat statements?
Right. So pgstat statements is still going to be your go-to when you care about per statement, per query information. So if you kind of already know, like, this query is really slow, then you want to use pgstat statements for sure.
Okay.
So the other thing I think people always wonder about with IO related tooling and Postgres, and specifically in this case, so once this is out there, like presumably I'll see something if I'm in a cloud provider, like I'll be able to actually get some data because the underlying stuff is often hard to understand.
Right. Yeah. So that's the great thing about pgstat.io is that it will, on any cloud provider, unless they restrict it for some reason, you'll be able to see it. We have put all the collection points in a place where it doesn't matter what the underlying storage type is or anything like that. So it'll just work on any cloud provider.
Awesome.
So I know you just committed pgstat.io to Postgres 16. I'm just curious what's next for you in Postgres. Are you going to continue to work in observability or?
I think that one of the things that I'm really excited about is Postgres 15 actually changed the underlying statistics system to use shared memory. And the way that it is now, it's much more reliable, and the adding new statistics is a lot easier and sort of straightforward. So what I'd really love to see is users who are not, necessarily full-time Postgres contributors, but know what their use cases are for them to add new statistics. And so I'm excited to review more patches around observability. I know some of the folks at Dalibo proposed some exciting new statistics around parallel query for Postgres 17. Bilal, one of my coworkers here who did a Citus Con talk on CI, he's thinking about working on some of the items the open items that I listed. So I think the goal is to have, people that are using Postgres being every single day, in the trenches, adding the new observability statistics.
Awesome. And people can reach you obviously today during the event on Discord if they have questions. And then more generally, if someone watches this talk on YouTube in 3 months and they have an idea for some statistics or feedback on observability, how do they reach you?
Well, you can tweet at me. I'm not that prolific, so I will probably answer. But I think the best thing to do would be on the hackers mailing list. You can either email me directly or you can send an email to the hackers mailing list and propose your idea, and sort of don't be afraid to don't be afraid to email the hackers mailing list, because you have a higher chance that people will respond. And if you want help composing your email, because I know it can be intimidating, I'm happy to help people with formatting and wording.
Awesome. Well, I'm so glad that you had this time on your schedule and the ability to come and give the talk today. Thank you very much, Melanie.
Thank you.
I also wanted to say that people who have feedback on your talk or any of the other talks, we've been popping a banner up with the aka.ms URL to fill out the attendee survey. And you can fill it out multiple times. So, on the talks you've seen in today's live stream, tomorrow's EMEA live stream, the on-demand talks, it's open until next Friday, the 28th or something. Cool. All right. So I've also been popping stickers and swag bag codes in the banners during the live stream. So those of you who care about swag, definitely pay attention to those banners as they pop across in each talk, so you can make sure to try to get your swag bag or your sticker pack. I think it's time for our 6th speaker today.
I believe it is.
Hi.
Welcome, Andrei Borodin.
Yes, correctly. Absolutely.
For those who don't know Andrei, he's actually, I guess, a longtime Postgres hacker. I guess we'll put you in that category now, and has worked on a whole bunch of different parts of the Postgres project. Most recent patch, I had a blog post on this a couple of years ago, like there should be a better way, so now there is, was adding iteration counts for the watch command in PSQL, which sounds like a small thing, but like it's a thing people need to do, and there was really no good way to do it. So
yeah, and this feature actually we added with Nick Samakhvalov on a live session on discussing which features we could add, and he proposed that let's do this, and we hacked it online and submitted to Postgres hackers, and it was committed. It was cool.
Awesome. A couple other things you've done, a bunch of work on indexes over the years, and you are one of the maintainers of WALG. Is that correct?
Yes, it was started by Dan Farina, but I later joined the team and organized all the stuff and moving around things.
So both of those areas deal with compression. There's a lot of other parts of compression in Postgres, and I think that's our topic for today. So let's
I just want to chime in too that
sure.
WALG, when it was first created, was Dan Farina was absolutely the mentor and the advisor, but it was actually a summer intern at Citus Data named Katie Lee, who I believe was a UC Berkeley college student at the time.
That's
so just wanted to throw that shout out to her. All right.
Excellent.
Andrei, over to you.
So, hi everyone, my name is Andrei. I'm doing Postgres every day. Sounds funny. Yeah, and I'm going to continue Melanie's talk with some more Postgres internals. And this talk will be interesting to DBAs and software developers to enable new features that are already in Postgres core, but also this talk could be of interest to scientists and someone seeking for new ways to improve Postgres in a classical algorithmical way with a compression, which is kind of an old field of study. So let's do it. On compression of everything that I could imagine. What is basic idea of compression? That we have a function that is reducing size of some input vector, and output vector must be smaller than input. But no, things just don't work that way. In fact, output is in so many cases is bigger than input. And what's the point then? Let's see compression as some way of a process of decompression as some way of a decoding tree. So we have a decision tree, and each decision is representing one bit of our input, of our compressed input that we want to decompress. If this decision tree is balanced, then there is a ratio of exactly 1, that the size of compressed input equals the size of decompressed input. There is no point in having a balanced decoding tree. So we want a imbalanced decoding tree. So some passes are short, but the vast majority of passes through the decoding tree is longer than pass through the balanced decoding tree. And that's the whole idea of a compression, that we have a trade-off, that some frequent data is shorter, but the vast majority of rare input vectors is much, or at least slightly longer than average input. And that's why we have to do this trade-off wisely. We cannot just apply compression everywhere. But the idea is sensible and it works. So in recent days, author of another database, ClickHouse, Alexey Milovidov, told on one of conferences that every byte that goes through I/O to the disk or to the network deserves some compression. And I largely agree with Alexey. And let's talk about compression deeper. What do we have in Postgres for compressing stuff? Let's talk about codecs. So coders and decoders. We always have these two functions to take a bit of vector of bits and make another vector of bits, and vice versa. Usually we use so-called Pareto frontier to describe useful codecs. Pareto frontier is a chart where on one axis we have a compression ratio, and another time, typically time for CPU, that is taken by compression. And if some codec have some codec have a data point which is not superseded by both axes, by some other codec by both axes, we say that the codec is on Pareto frontier. Here we can see that on a higher timings and better compression ratios, we usually have a LZMA compression, which is a lamp-LZ and Markov chains algorithm. And on the right side, we have a faster codecs, which consume a little of CPU and have a modest compression ratio. And so for our database, we have some variable resources like memory, but it's not affected much by compression, and CPU time and I/O time, I/O throughput. We have almost from the beginning of popularity of Postgres, codec which is called PGLZ. This is a codec which was implemented by Jan Wick back in 1997, and it was proposed in scientific paper as a simple compression algorithm back in 1993. So it's old, it's not super efficient, but the main advantage of this codec was that it wasn't covered by any kind of patents, so it could be used in open source, and this is a relatively important thing for software. Later, we had a new codec which is called zlib. It was standardized by IETF with RFC document. It had a good implementation back in 2000s, at the beginning of 2000s, and from Postgres is using zlib 2. It is slightly better both in compression ratio and in compression performance, but it was not that importantly better than PGLZ to replace PGLZ everywhere. Later emerged another codec, LZ4, which is a compression optimized for performance. It has a very modest compression ratio. Usually it compresses like normal data, some average data twofold. Compression ratio is around 2. But the main advantage of this codec is that it's decompressing almost with the speed of memory. So we see here that just copying bytes is 14 gigabytes per CPU core, and decompressing LZ4 is 5 gigabytes per CPU core, which is a very impressive result. And later, author of LZ4, Jan Collet, tried to supersede LZ4 with the standard codec, which was expected to be better on Pareto frontier than LZ4, but it actually didn't. LZ4 is still super fast, and the CST, even with a lower compression level, is not always faster than LZ4. But this standard is a main point on Pareto frontier for database applications, for database systems, and is widely used. And all these codecs are currently used in Postgres. Let's see how they are used. No, sorry. One more thing. Another thing that emerged relatively recently with codecs, that typically we have we need to provide codec some runaway to unfold the effective compression. But in database, from time to time, we have to compress small datums like strings of a few hundred bytes. But for example, the standard and the LZ4 are almost indistinguishable in a compression ratio on sizes of a few kilobytes. But to help with compression of small datums, small data, we can use compression dictionaries, which is a prefix of, like, virtual prefix of every data that must be pre-computed on some corpus prepared before we compress anything, and then it helps codec to compress frequent but small byte sequences. So all in all, we see that codecs became much better in recent times. And here is a quote from Michel Paquet from PostgreSQL Hackers, that modern compression algorithms became really useful for databases. And I'd say that in last 3 or 4 years, we made a huge advancement in Postgres core to use better compression algorithms. Let's see what's there and what's still to do. Use cases in Postgres. First of all, surely in Postgres 14, you can use better compression for toasts. The oversized attribute storage. This is just a joke. No, don't use varchar to use text. Everywhere, text is just fine data type. So, most useful application of compression is compression of toasts. Previously, they were compressed with PGLZ. Now you can use it for text columns. And when you create a column, you can say that this column must be compressed with LZ4. Unfortunately, that's not a default. So you have to alter table and set this compression yourself. Default is still PGLZ. But this setting will make reading toasts much faster. On average, LZ4 is faster, approximately 10, like from 5 to 10 times faster than decompressing PGLZ. Another application of a compression is a base backup, like PG base backup. Recently, there was a new compression method added, and you can say that compression must be done on a server. What's the difference? You can ask. And the actual difference is that network bandwidth is a super important resource when you are downloading a backup from a running OLTP installation, you're consuming a network which is used for queries, for replication, for wall archiving, for lots of very important stuff. And in many cases, the limiting resource is not a storage, is not a storage quota or storage place on a disks, storage empty space on disks, but rather network throughput of highly loaded installation. But actually, there are so many other backup tools like ValG or PG Backrest or Barman or I don't know, PG Pro Backup, Arman, and many others. Very good backup tools which can be used for backupping, and they are actually already doing compression of base backup. But anyway, it's good to see like good architectural decision made in core and not in external tools. Another interesting idea is the compression of wall, right? A head log. Let's see what resources wall can consume. We see here that typical highly available Postgres installation is sending wall to archive for point-in-time recovery purposes. It is reading wall from disks. It's writing wall for crash recovery on primary. It's sending wall to each of replica or to each standby instance, and actually writing this wall on each standby instance on disk. So if we, for every single byte, if we reduce amount of wall written a little, we actually save a lot of resources in different places of a whole installation. So it kind of makes sense, but compressing wall before writing it on disk is a very tricky thing. Here are some problems of wall compression. For example, actually all records are relatively small. They are typically like on a scale of tens of bytes, like smaller than 100 bytes. And these chunks are not easily compressible, even with modern algorithms. But still they are compressible, especially when they are going one after each other. Another problem is that if we compress wall before writing it on segments to disk, each wall sender will have to recompress it, and wall receiver have to compress it again. And finally, crash recovery will be even more complicated than it is now. And in fact, a code of Postgres crash recovery is very difficult for a newcomer to read. It's super well documented. So it's very well documented, but it's simply complicated. And in case of a compressed wall, it will be much more complicated because we have to continue writing the same wall segment. And modern algorithms simply do not allow you to add data to already compressed data. You have to extract everything and compress it back with some suffix. But a very small compressed chunk can constitute a very large decompressed chunk, and you even cannot predict how many memory you will need to decompress few bytes, because every few bytes can be like a bomb of decompressed stuff. Anyway, I think at some point we will have a wall compression because it saves us a lot of computational resources, a lot of disk bandwidth and network bandwidth with a very teeny fraction of CPU time. But now we are already compressing full page images and starting from Postgres 15, as far as I remember, you already can use LZ4 to compress full-page images. I contributed this patch together with Justin Prisby and, of course, reviewers and help of community. Yeah, according to my measurements, it makes average installation of about 10% faster under pgbench. And also you can use the standard for full-page images compression too. But on a scale of single page image, I really did not observe real difference between these two codecs. So they both are much better than PGLZ, but still we need to make something more clever with FPIs to make the standard really show off. I think that good idea would be to compress all page images together, like having many page images that go one after each other. They could be compressed together to make compression more efficient. Or we could try to keep a context of a compression between different compression cycles, but it will complicate crash recovery. So still, it's trade-off of complexity and efficiency, not just of compression ratio and compression time. Also, community is working on protocol compression, like compression of libpq protocol. It is sometimes the thread is redirected, sometimes it's returned with feedback. And currently, the main concern is that compression is in fact defeating TLS, defeating encryption. What's the problem here? Let's see what is a crime attack on a compression before encryption. If we compress together some secret data with some user-controlled data, the whole idea of compression is making some more frequent data sequences shorter. But how do we know that some sequence is more frequent? The answer is simple. If the byte sequence is self-resemblant, if it is repeating itself, then we think it is like more frequent. So any compression is working better if the data resembles itself. And if we have compressed secret data with user-controlled data, user can judge, can extract information on the resemblance between secret data and user data. And if the user is observing size of encrypted data on public channel, they can judge how efficient it, what is actually the secret data. And if attacker can repeat again and again the same query, they can eventually extract secret data from encrypted channel. It's very theoretical attack, but plausible. That's why we don't have a compression in OpenSSL implementation and other TLS implementations. But still, compression of protocol will save us a lot of resources. So at some point, we will have to have it, despite of some security risks. Another wild idea of using compression is compression of temporary files. Like temporary files will go through I/O, so that's why they deserve a compression. I've hacked a patch. Here is just a screenshot of Postgres hacker's message about this patch. It somehow works and allows to reduce 4 times number of bytes written during create index operation or hash join operation, but the implementation is just too difficult, just too complicated, and not usually worth it. Like it's always like trade-off between maintainability and profit for end users. And so far, the patch is not in the shape. What's the basic problem of this patch? It's based on the idea of random access compressed file. And each page after compression have a different size. It can be wider than it was, more than 8 kilobytes. It can be slower. It can be smaller than it was. And at some point, pages will be deleted. And actually, defragmenting temporary file is sounds like nonsense. But still, when we write something in the middle of a temporary file, we will have to defragment it somehow. And this complexity currently prevents me from going further with this technology. There are some alternatives available. For example, in Postgres Pro, it's a proprietary fork, closed source, but they have compressed file system. Compressed file, or maybe it's not compressed. I know they call this technology CFS, and this is effectively compression per page. I know that it works sometimes on some workloads. Very well on some workloads. Another option is just to use a compressing file system like ZFS, BTRFS, or some others. Another development direction is to just go on with a defragmentation of random access compressed file. But the problem is that we actually have to do it durable, and if we want a durable defragmentation of temporary file, we will have to log temporary file, and this is just I'm hesitant to go on with this. And another interesting idea is a approach taken by Greenplum team. They identified that hash join do not require random access. It's always sequential, and they extended buffer file API with a pledge sequential method that is saying that this temporary file will be never read from in the middle, never written in the middle, just compress it as sequential. And it is usable, but I don't think that patch as it is in Greenplum is any close to committable in Postgres right now. So if you want to remember something from this talk, then first thing that we try to compress frequent data, and rare data can be longer than before compression. And the other idea is that any bytes that goes to disk or to network deserves the compression. If you have some good ideas on compression in database, I'll be happy to discuss it with you in Discord. Also, maybe you have some scientific ideas how to make recompression in popular algorithms, and if you are willing to work on LZ4 and CEST to have this API, that would be great. And basically, that's it. I'll be happy to discuss this stuff with you in Discord. Thank you so much for listening.
All right.
Thank you, Andre.
Thank you. That was pretty good. A lot of information packed into a short period of time. So nicely done.
Is that a pun? Is that a pun, Rob? Come on.
Maybe. Could be. It's late in the day. Could be a pun. I did want to ask a couple of quick questions, if you don't mind.
Sure.
So one for sure is, I think most of the research, essentially you touched on some research that is not from academia. I always feel like most of it comes from academia. And some of it is even papers that were written 20 years ago that we just never looked at for some reason. I'm curious, how do you feel about the state of taking that information and then being able to transform it into a way that's useful for production systems? Both there's a technical issue there, I'm sure, but also legal ones around patents and that kind of stuff. Any thoughts on that?
Mm-hmm. Yeah. Well, a lot of very good research was done in in the times when patents were a thing, and we cannot just use anything that is patented, because like it's a project policy. And another thing is academia is like doing the job well in a on a broad scale. They see us like database developers as just one application, and they are producing algorithms that are like general purpose algorithms. Yet I feel that we could have algorithms that better suit our needs in databases. And if some researchers are watching us, so I'm asking you to think more about how we can adapt API, because in databases we usually have pages. We usually have we usually have something like tuples. We usually have to add some data into already compressed data, and we have so many like ways to test compression algorithms which suit our needs better, and we have standard ways to measure performance of overall system, not just a compression system. If your algorithm is like pressing CPU in some extraordinary way, we will see it in a system working as a whole, not just one isolated part. So that would be great if some researchers would join this together with database scientists and database developers.
The code is there. They should join us. I agree, totally.
A call to action.
Absolutely.
Call to research.
So we'd love to talk to you more. I'm sure people have more questions. There's probably some on the Discord. If you're going to be popping over there.
Yeah, okay. Sure.
All right. And are you going to be at the EMEA Livestream, which is happening 9 a.m. Central European Summer Time tomorrow? Yeah.
I will try. I'm planning to watch Marcus Slot keynote, and probably I will stay for some other talks too.
Awesome. Well, thank you again, Andre, for being part of this. And your talk will be available for people who want to watch the replay of the Americas live stream. Maybe if they got here late, they'll be able to watch it there. And then we'll be publishing it as its own independent talk on YouTube within the next couple of weeks.
Cool. Thank you.
All right. Thanks, Andre.
Thank you.
So now it's time to go to the wrap up. And it's you and me. Right. Our wrap up is supposed to be like 25 minutes, but we're going to have to go fast, Rob.
Yeah. I was going to say, like, I can't tell if it was a long day or like a short day, because it seemed like it went by pretty quick. So, but that's good. That's good.
It did go by really quick. And especially paying attention to the chat and trying to pay attention to the talks. And I forget about live tweeting. Thank goodness that other people are out there doing that. So we have a couple things that we wanted to cover in the beginning. So let's see. The first is just that reminder that there's a survey. And you can quickly scan that QR code. You can enter the survey feedback multiple times. So if you haven't watched all the talks yet, you want to watch some of the on-demand ones or whatever, you can do it multiple times until it closes next Friday. So
vote early, vote often.
Vote early, vote often. That works.
Yeah.
I feel like it's a broken record. I've mentioned the Discord umpteen times. So there's a word for when you say a word so many times that it loses its meaning inside your head.
Sales.
No. And actually that word was on a Ted Lasso episode recently, but that's another story. And I just can't recall what it was. But anyway, I have said the word Discord so many times today. But there is a kind of a fun back channel there for those who want to join. And it's going to continue throughout the rest of the day. Wow. Big thank you to all of these speakers. This is pretty cool. And I have the URL showing for the live stream playlist, Citus Con live stream playlist right now. And that's why I popped this up there. And then if you want to mark your calendar, I want to make it easy for you. If you want to go to all or part of the EMEA live stream, because who knows where you are in the world, you might be watching this in replay in a couple hours, and maybe you live in Europe. So the link in the upper right corner, aka.ms/CitusCon-EMEA, that gives you an easy way to drop something in your calendar for the EMEA live stream tomorrow. You'll be asleep, Rob.
However. I hope so. I mean, I do want to watch this. I will definitely watch the replay of it, but I don't think I will watch it live.
Got
Something
it.
will have gone really wrong if that happens.
So on-demand talks, there's 25 of them.
That's a fair number of talks, but they're all really, well, I don't know. I assume they're all really good because I've looked through the list. I've been trying to also peruse that along with these other things we have going on today during the live stream. Was like looking through that list of talks and seeing what was there. And I'm really excited. Actually, I will be watching some of those tonight before things happen tomorrow. So for my tonight.
Well, and you gave a really interesting on-demand talk last year. And I know that, those views, they don't all happen on the day of the event, right? They happen over time. There's a whole long tail. And so the good news is people can consume it at a time that's convenient to them. But obviously, for anyone who is interested in a particular topic, if they hop in there today, tomorrow, then they can ask questions on the Discord. And actually, it's a little bit easier to reach the speakers. Yeah. Unless those speakers are at KubeCon. A few people are distracted with KubeCon.
There are other conferences going on?
There are other conferences, I know. There's a Microsoft MVP Summit, too, for people who are involved in that. So we have a couple of promo videos, and I wanted to play that first one that is all about Postgres performance and security that goes through super, super fast, like 10 seconds each for some of these on-demand talks. Does that sound good?
That sounds awesome.
Okay, let's go.
But in fact, I'm going to show you different, hopefully exciting ways that you don't know about to index UUIDs in PostgreSQL.
So if you are a traveling Postgres consultant like me, so you will see that often a lot of performance can be gained by outsmarting people, right?
Today I'm going to be talking about Postgres table flow, but the overall idea of this talk is discussing the transition from doing Postgres at a smaller scale to Postgres at scale.
I'm going to talk to you today about PostgreSQL privileges, roles, and security, and how you can take better advantage of them within your Postgres installation.
The thing I wanted to talk about, explain the concepts behind tuning high-write workloads for Postgres, and then dive deeper into the specific configurations.
I'm DevOps Data Technical Lead of JFrog, and I want to share my lecture about troubleshooting high CPU utilization for Postgres database.
We'll talk about external attacks, about authentication security, about data protection, and also I will share some tips and my recommendations with you.
So much goodness. So here's the thing. I have to say, I got a chance to look at Hockey's slides a little bit and just started like peeking at that. And that will be one definitely I'm watching tonight because he definitely goes into things like I felt like I've dealt with UUIDs a lot in Postgres. He does talk about some stuff in there that I don't think I've seen anyone else actually talk about before. So maybe I missed it, but I'm super excited on that one. And I would also say like Ryan, I know has been doing a lot of advocacy work around roles and grants. So I'm pretty excited to check that one out as well. And I mean, they all, I think, look interesting, at least on first glance. So that's pretty good.
Yeah, I think Ryan gave a talk at Scale, and you were there as well. I don't know if you saw that one. And then Chelsea Dole, I saw her give a lightning talk at PGConf.eu in Berlin a couple of months ago, and yeah, she was fabulous. I went up, introduced myself, told her all about Citus Con, and said, "Please submit a talk proposal." Although, I mean, the talks that got accepted into Citus Con is pretty competitive. I think we had like a 27% acceptance rate. So 32 invited keynotes, obviously, but 35 talks accepted. So you can do the quick math in your head and figure out how many submissions there were. There were a lot of phenomenal submissions, and it was really hard for the talk selection team. And in fact, I think I have a slide here. If I click ahead. Yeah, there it was, just to say thank you to everybody who was on the talk selection team. Aaron Wislang, Alicia, Marco, and Charles spent a lot of time reviewing all those proposals. And this conference, obviously I say every great event starts with great speakers, but the talk selection team does a lot of work to get us there.
Absolutely. And, again, they made sure not to invite me back. So I think the level this year has gone up even more considerably. So that's
Ouch.
awesome.
Don't be self-deprecating. Swag, for those of you who care about swag, the code is on screen right now, as well as the URL. There are 75 of these being given away in this live stream time period. So if you haven't gone to do it yet, the activity book is fun, not only for kids, but I remember when I first met Melanie Plageman, it was because she had gotten the previous version of the activity book at a Postgres conference, and she was enjoying coloring in it. So yeah.
Nothing better for when you are waiting on an index rebuild, than to be able to whip out the activity book and, pass some time that way. So.
And socks are always cool. And there's the sticker packs too, for those of you who use stickers either on your laptops like me or on your luggage. I feel like I'm in an infomercial, but I know how much people care about swag. It's like, it's a thing. And
people
so
like stickers.
Yeah, they do. Okay. We have another quick video trailer. This one is focused more on the two Azure database services for Postgres, Azure Cosmos DB for Postgres, what I happen to call Citus on Azure because I'm such a Citus open source person, and then also Azure Database for Postgres Flex Server. So let's roll this promo. It's number 2, unless you want me to do it.
Hey, Lucas here, and I'll present to you how I auto-scaled a Cosmos DB for Postgres cluster using Citus, of course, Grafana, and Azure Serverless.
This talk is for multi-tenant SaaS companies who are growing fast. That is, they're onboarding thousands of customers, and they're expecting or already running into scalability issues with their database and want to scale out with distributed PostgreSQL.
So today, we are going to talk about multi-tenant software as a service applications on Azure Cosmos DB for PostgreSQL.
It's built upon like the community version of Postgres, so the open source Postgres, and adds also Citus extension, which turns Postgres into a distributed database.
In this session, I would like to talk about partitioning in PostgreSQL and how it is similar and different than Oracle.
So today's focus of the talk is to discuss some tools, recommendations, and best practices of how to reduce cost on Azure database for Postgres flexible server.
My talk is about Azure AD authentication with flexible servers. If you use flexible servers or plan to try it out, this feature will help make your application connections more secure. It will save your time managing credentials and roles, so please check it out.
Awesome. I'm not going to be like every one of these is awesome. So, but I will pick one in particular that I have to say. So I've seen a lot of chatter about multi-tenancy deployments in Postgres lately. Super hot topic, and it's like it's come back into fashion, I guess. So that one I'm super interested to see, because to me, I don't know if people always think of Citus as a multi-tenancy solution. But clearly it can be used for that. And so
that means I wasn't doing my job. I mean, before the acquisition, when we came out with the worry-free Postgres tagline, because we decided that most people only had 30,000 days in their life, and time is our most precious resource as developers, as engineers, as people who manage databases. And so we were like, you know what? People don't want to wake up at 3 a.m. to deal with Postgres database issues. And so let's focus on worry-free Postgres. But the other alternative at the time was to kind of really focus on driving home the point that Citus was a multi-tenant database. So maybe you don't connect those dots because we focused on that worry-free angle. But
well, I think for me, yeah. So the worry-free was definitely a big part, but also I think using it for like statistics, monitoring, OLAP, like that type of stuff, like we saw in the earlier talk with JSON and,
You're right.
and doing that monitoring piece. To me, I think a lot of people connect it with that type of a workload. And so that's the reason why I say that. I don't know if everyone connects it with both sides of that. It's good for both of those, really.
Yeah, no, and it is good for both, and we have tried to serve both of those use cases, both multi-tenant SaaS and real-time analytics. But I'm not here to promo the project right now, although I did just pop up the GitHub URL on screen. Okay, so let me see.
I'm going to promo while you're prepping the video. Go on GitHub. It's all open source. Again, this is one of honestly one of the reasons I'm here. It's all open source. It's on GitHub. Star and watch the repo, all that good stuff. Would recommend to anyone who's interested in Citus. There's a lot of interesting stuff that goes on over here. So,
Well, you've been a supporter of the project from far away for a long time, and I really appreciate it because a rising tide floats all boats. Like, I'm a big fan of other projects. I love the fact that Lucas did a demo with Grafana, which I'm a huge fan of, and I think it's good when we support each other or recommend. The whole word of mouth thing is useful in the developer world. We have a couple of other, I know we're tight on time because we have to end in just a couple of minutes, and we have 2 more videos we want to roll. So let's go ahead and roll video number 3, please.
So this talk, we're going to discuss a little bit why you want to run a database on Kubernetes, how this was done to run Citus, to create Citus clusters before Patroni 3.0 appeared, and the most important thing, how you can run Kubernetes, Citus on Kubernetes today with open source software in a very, very easy manner.
In my opinion, cybersecurity applications have a certain unique set of features and requirements that are different from other applications. I also think that Citus database is very uniquely positioned to solve many of the challenges that cybersecurity applications present.
I'm a principal engineer working on the platform here at Jellyfish. Been here since the early days and through a lot of our growth and our infra choices, including the move to a sharded database that we're going to talk with you here today about.
The purpose of this talk is to help get ahead of some of the gotchas that come up when trying to move to a self-hosted Citus implementation. We went through this journey, and we'd like to share some of the interesting technical challenges that we had to solve.
Because I frequently get questions about foreign key support in Citus. In this talk, I want to clarify some of the concepts regarding Citus.
Hello, I'm here today to share with you some lessons and observations from Safety Culture's migration from a managed PostgreSQL service to our own self-hosted Postgres.
Also another fine slate of talks, especially like the one moving to the self-hosted from the managed. That's really complicated, and I think will explain to a lot of people what they're getting into. So
yeah, it was a pleasure for me to meet Matt Klein and Delaney McKenzie from Jellyfish as they told that story. Although also Paul Diadny told a similar story about moving to a self-hosted Citus environment. So obviously, I work at Microsoft, and for people who want that managed service offering, we offer that. But I love seeing people be successful with Citus open source too. Okay, so I think we have, let's see, another video here that's some more Postgres community talks. So let's take a look at these.
I am Dimitri Fontaine, and I've been contributing to PostgreSQL for a very long time now. We're going to talk about how to copy a Postgres database, so from one server to the other one.
The concept of storing time with databases had been popular for a very long time, pretty much since relational databases come to life.
And secondly, the goal of this talk is to talk about how Postgres can give you an ideal platform to use artificial intelligence in your applications.
We'll set the scene by imagining that you're the DBA in an organization that needs to implement multi-tenancy.
What I'm going to talk about today is how we've taken PostgreSQL, a nice, sane relational database, and how we've twisted it and molded it and created what we think is a very robust document database and event store solution.
Today, I will talk about in-depth guide to the Postgres' new CI, and I will explain how to use that new CI.
In this talk, we'll see together how to build web maps from scratch using Django and PostGIS. If you are asking yourself what type of maps we can build with Django, Let's see an example right away.
Okay, that's a
All
lot
right.
to unpack. So there's a playlist. Well, actually, just go to aka.ms/on-demand, and you can get access. Just go to the schedule page, and all the on-demand talks have YouTube embeds there on that on-demand tab, and so you can track down any of these and start watching. So much goodness. I actually promised somebody I would pop up a slide. I know we're almost out of time and we got to talk about what's next, but I am just going to pop up this slide like I promised. For people who do want to learn more about Citus on Azure, this new Azure Cosmos DB for Postgres training guide came out a couple of months ago. I think it was maybe October. Joe Nelson on my team was involved in the creation of it, not on my team, but on the broader team. And it's everybody's recommending it. So if you're new and you want to try this out and get started, and you want to try it on Azure versus, just downloading the open source packages, this is a really good place to get started.
I thought it was going to be a free Kesha slide, but I guess this is much more useful and much easier for people who want to get started and check out some of this stuff. So
free catch up. Okay. All right. So what's next? We're a few minutes over time. I just wanted to flag a couple of things. The first thing is, if you're going to be awake during the EMEA live stream, which is, not that far away now, it's happening on Wednesday at 9 a.m. Central European Summertime. You can add it to your calendar with that URL in the top left. Let's see. No, is that right?
Yes.
Attend EMEA. And then the link on the replay, the Americas live stream, is wrong. So the link on the replay of the Americas live stream is what I'm popping on the bottom of the screen now in a banner. So sorry about that, folks. And yeah, the Discord. Discord. What does Discord really mean?
I think we'll have to save that discussion for another day.
Okay. Rob Treat, thank you so much for being my co-host and being here. I know you don't work for Microsoft. You're not part of the Citus open source project, but you are part of the Postgres community, and it has been a delight. Truly.
It's been my honor. Thank you so much for having me.
And thanks for everyone who joined us, and hope you check out the rest of the Citus Con talks. And